The handouts or review materials must be treated with utmost confidentiality. It shall be the responsibility of the person whose name appears therein that the handouts or review materials are not photocopied or in any way reproduced, shared, or lent to any person or disposed in any manner. Any handouts or review materials found in the possession of another person whose name does not appear therein shall be prima facie evidence of violation of RA 8293. Top-notch review materials are updated every 6 months based on the current trends and feedback. Please buy all recommended review books and other materials.
Hi, good day. I am Dr. Prince Rubio, a Year Level 2 IM resident, and I am your lecturer for your first part of biochemistry, structural biochemistry, and nutrition. So I am here today to highlight important concepts in biochemistry and synthesize and simplify complex concepts along the way. So, sa ating mga topics here, I'm also going to highlight important clinical concepts that can be useful also in IM, Pedia, and OB-GYN. So guys, sit back and relax and chillan tayo dito. Mamaniin natin ang biochemistry for the PLE. Okay? So in my every lecture, here's my outline. So we're going to discuss here a review of chemistry concepts. Then next, structures of your macromolecules, heading to nutrition and vitamins and minerals, and of course, some minor concepts in nutrition. The complex molecules, enzymology, and of course, lastly, digestion and absorption of your macronutrients. Now, before we go to hardcore biochemistry, let's first talk about the language of the biomolecules, okay? Some review of chemistry concepts, and these, okay, are testable for the board exam. So, take note of these concepts. So, a chemical reaction refers to the process in which a substance or substances is changed into one or more new substances. For example, burning the love letters of your ex. Ex na siya eh. Iniwanan ka na niya. It's time to dump the letters and sunugin siya in the process. So you add heat. You apply heat, and because of the heat, nagbabago siya. Yung paper na may ink, nagiging siyang carbon monoxide, your primary pollutants, etc. Okay? So this is a very important concept known as a chemical change or chemical reaction. Okay, pero Doc Friends, what if I cut the love letters of my ex into smaller pieces? Doc, sadly, it's still the love letter of your ex. Punit-punit nga lang siya. Ang tawag dyan ay physical change nga lang or a physical reaction. So if gusto mo talaga mawala at bago yung letter ng ex mo into ash afterwards, perform a chemical reaction. Now for the next concept, let's discuss the anatomy of a chemical equation. A chemical equation is simply the visual representation of the chemical reaction, and it uses chemical symbols to show what happens during a chemical reaction. The plus sign here means to react with, and the arrow sign means to yield or to become. So when you read this equation, it's actually molecular hydrogen reacts with molecular oxygen to yield or form water. Now, there's a difference between your reactants and products. Reactants are the starting materials of a chemical reaction, and they are found on the tail side of your arrow sign, while products are substances formed as a result of your chemical reaction. They are found on the arrowhead side of your arrow sign. Now, reactions can be classified based on reversibility. Reversibility means that you can convert the products of a reaction going back into its original reactants. So kanina, the previous equation represents an irreversible reaction because it only has one single arrow. But reversible reactions are represented by a bidirectional arrow, one pointing to the right side, one arrowhead pointing to the left side. Now, the arrow pointing to the right side represents a forward reaction, wherein the reactants becoming the products, while the arrow pointing to the left side represents the reverse reaction, the products becoming the reactants, back to its original form. Now, let's talk about the movement of thermal energy between their chemical reactions and its surroundings. Okay, guys? Always remember the prefixes and suffixes of our terminologies. An exothermic process, okay, occurs when the heat generates from the system of chemical reaction going outward to the surroundings. So, exothermic siya, palabas from the reaction going to the surroundings. While an endothermic reaction, heat is moving from the surroundings going to the small system of chemical reactions. Again, guys, exothermic, palabas, exo, going to the surroundings ng heat natin. Endo, papasok sa ating chemical reaction. Now, enthalpy and entropy are different. Enthalpy refers to the energy of the reaction, while entropy refers to the degree of disorderliness. Ang ibig sabihin niyan, mas magulo ka, mas makalat ka. Take for example, this glass of water, okay? Pag ang tubig dito, guys, ay natapon ko sa aking table, kakakalat siya ng sobra-sobra, di ba? It's a form of entropy. And universe has a tendency to become more disordered in the process. Universe loves entropy, but only life is trying to find order in this universe of disorder. Okay, that is the analogy, okay, with entropy and the universe and life. Now, let's talk about thermodynamics, the study of your heat transfer and its relationship with the universe and the different systems. We have 4 laws. Now, the very basic law is the first law of thermodynamics. The one you first encountered. The first law is the one you first encountered during primary schooling and secondary schooling, wherein energy is neither created nor destroyed but only transformed into one form to another. For example, light energy coming from the sun becoming stored as chemical energy, okay, inside the leaves of the plants. That is a form of first law. Okay, nagbago siya ng form lang from light energy to chemical energy, but still, hindi ka gumawa ng panibagong energy. Nagbago lang yung form niya. Now, the zeroth law refers to this concept. If two bodies are in thermal equilibrium with a third body, therefore, these two bodies are also in equilibrium with each other. It's basically the transitive property in mathematics, right? If A is equals to C, and B is equals to C, therefore A is equals to C. Second law is now about entropy. And ang point niya is that entropy increases in a spontaneous process. While lastly, third law states that entropy of a system approaches to a constant value when temperature reaches absolute zero. It actually makes sense because temperature reflects the movement of the molecules of matter. When the molecules are rapidly moving, there is actually high temperature. But when the molecules are slowly moving, okay, you have lower temperature. And if you have absolute zero temperature, molecules are standing still, not moving at all. Therefore, entropy won't happen. Entropy becomes a constant value when temperature reaches absolute zero temperature. Now, to understand better your heat transfer method, you have to know the sign conventions. Now, for an endothermic reaction, enthalpy is positive. Okay? Kasi you're trying to put it in the system. Okay? Enthalpy is positive. But entropy is negative because coming from the surroundings, ginagawa mo siyang compact in a single structure. Mas ordered siya in the process. So, entropy is negative in an endothermic reaction. But in an exothermic reaction, enthalpy becomes negative because it is being released to the surroundings. But entropy becomes positive kasi kumakalat siya into the surroundings, diba? So, mas meron kang disorder. Therefore, in an exothermic reaction, you have a positive entropy. But take note that when the forward reaction has a positive value of 570, for example, the reverse reaction will still be the same magnitude but only of different sign convention. Okay, so take note of this concept. Now, let's talk about how do we transfer heat from one matter to another. So, the first method is known as conduction, which occurs when heat is transferred directly between objects. For example, gutom-gutom ka na, di ba? Gusto mong kumain ng corned beef na palm doon sa ating plato, di ba? Hinawakan mo siya agad, mainit pa. Heat is transferred from the corned beef to your hand. that is conduction happening. While in convection, it's the heat transfer occurring via movement of fluid, the air or water, when the heated fluid is caused to move away from the heat source. However, in radiation, heat is transferred pero wala kang medium in between them. For example, the sun, then the earth. Okay, there are gas molecules between earth and the sun, but very minimal, very negligible in amount. So, hindi sila enough para makatransfer ng heat via convection and via conduction. Now, heat is transferred here via electromagnetic radiation. So, yun ang ginagamit natin in the form of light para matravel siya. Now, in the spectrum of light, there is what we call as ultraviolet, UVA, B, and C. Now, UVA can actually accelerate aging of the skin. UVB is actually very associated with skin malignancies. And UVC is the one not screened by the ozone layer. Okay, so those are the clinical aspects of your ultraviolet radiation. Now, to better understand the different biochemical reactions, you must differentiate oxidation from reduction. And take note that these reactions always occur together. When a substance is oxidized, the other substance is then reduced. Now, oxidation is losing electrons and hydrogens, but gaining oxygen. And when involved in metallic ions, there's actually an increase in oxidation number. For example, from the ferrous state of 2+, bigla siya magiging ferric state of 3+ of iron. May increase of +1. And oxidation is involved in the release of energy. Hence, it is mainly involved in catabolic processes, which is the breakdown of substances to its simpler forms. For example, a large protein molecule becoming smaller amino acids. That is catabolism. Now, the oxidase agent here, in the substance involved here, becomes the reducing agent of the reduction side. As mentioned, redox reaction occurs together. In the reduction, there is a gain of electron and hydrogen, but there is losing of oxygen. Therefore, you have a decrease in oxidation number. And take note that reduction is mainly involved in storing energy, same in anabolism, wherein it involves the synthesis of larger molecules from simpler substances. For example, the amino acids becoming large chunks of protein. That is anabolism in the process. And of course, the reduced agent in this process becomes the oxidizing agent for the oxidation process. So to have a quick recall, always remember the famous mnemonic, Leora and Geroa. Leora loses electrons or oxidized. And you become the reducing agent of the reduction process. While in Geroa, you gain electrons, you become reduced. And you become the oxidizing agent of the oxidation process. Now, in this slide, I would like you to highlight these terminologies. Polar substances and charged substances are always hydrophilic substances. They are water-loving. They love water. While non-polar substances are water-fearing. They're hydrophobic. Takot sila sa water. And substances with similar characteristics will dissolve in each other. That is the like dissolves like concept. It means non-polar substances dissolves in a non-polar medium. For example, a large amount of triglyceride can only be dissolved in ether or alcohol, since both of them are non-polar substances. While polar substances naman dissolves in a polar medium, so same banana. So therefore, polar substances like electrolytes can be dissolved in water, a polar medium, because water is a polar substance. Now, the power of hydrogen, abbreviated known as pH, is defined as the negative logarithm of the hydrogen ion concentration of a solution. Basically, it measures the acidity or alkalinity. So, if you have a higher concentration of hydrogen, the lower the pH, and vice versa. Because in bases, they have a high pH, they have a low hydrogen concentration. Guys, don't be confused in this concept. Now, take note that in physiological fluids, The average is 7.4 and the range of 7.35 to 7.45. By definition, acids are substances that donate protons. Like for example here, acetic acid. Okay, nawawalan siya ng hydrogen atom afterwards, it gives it to water. Okay, you become acetate in the process. Therefore, as a proton donor, you are an acid. While bases accepts protons. For example here, ammonia. Okay, it gained one hydrogen ion. Naging siyang ammonium ion. So, nag-gain siya ng proton, ang tawag sa kanya ay base. So, again, acids are donors of protons while bases are acceptors of protons. Now, don't be confused with pKa in pH. pKa value expresses the strength of acids. And the pKa value of acids is inversely related to its strength. Meaning, the lower the pKa, the stronger the acidity. While the higher the pKa, the weaker the acidity. Now, let's first talk about valency. Now, carbon atoms are known to be tetravalent. They can form 4 bonding. Trivalent ang ating mga nitrogen. They can form 3 bonds. While oxygen are divalent. They can form 2 bonds. And lastly, halogens and hydrogen are monovalent. They can only form 1 bond. Now, in the concept of chiral carbons or an asymmetric carbon, same lang po yun, it refers to a carbon with 4 different or 4 unique atoms or groups of atoms attached to it. So, the chiral carbon here is the one at the center. So, iba-iba sila. Iba ang ating hydroxyl sa ating hydrogen, methyl, and ethyl group. There are 4 different atoms or groups attached to this carbon. Therefore, it is also known as a chiral carbon or asymmetric carbon. Now, in this case, guys, the alpha carbon refers to the first carbon attached to a functional group. Now, in your handout, please take note of the different functional groups, familiarize with them. The functional group here is your COOH. Okay? It's the whole functional group, yung segment na to. Okay? Therefore, the first atom attached to it is known as the alpha carbon. Next to it is the beta carbon, gamma carbon, and so on. Okay, that is the concept of alpha carbon, etc. Okay? Now, pag ang last carbon dyan, ang tawag doon ay omega carbon, serving as the last letter of the Greek alphabet. Now, we head to the real biochemistry. Let's head first to the structures of your amino acids and proteins. Now, guys, take note, amino acids are the most abundant organic molecule in the human body. But, when you talk about the most abundant organic molecule in nature as an overall, these are carbohydrates. Now, amino acids, only 20 are commonly found in mammalian proteins. And they have the following structure. You have an alpha carbon at the center. We have here an H molecule, a proton molecule. We have here an carboxyl group, the acidic nature of your protein. We have here the amino group, the basic property of your amino acid. And we have your side chain, which functions as a way of determining the properties of your amino acid. Kaya siya amino acid. Meron siyang amino group becoming the base and the acid group representing the carboxyl group. Now, that is the usual structure except for proline. Proline is actually an amino acid. Okay? Meron kang cyclical structure here, making it an amino acid. Most amino acids, as mentioned, are alpha amino acids, wherein both your amino group and your carboxyl group are attached to the alpha carbon. Kakaiba siya in this following amino acids. They are non-alpha amino acids. Beta-alanine, beta-amino isobutyrate, and gamma-amino isobutyrate. Now, moreover, amino acids are chiral in nature. Okay, as mentioned, a chiral carbon, you have 4 different unique constituents surrounding it. At least 4 sila, di ba, dapat? Since carbon is tetravalent. You have your hydrogen, the carboxyl group, the amino group, and here a unique side chain. But this does not occur in glycine. Because in glycine, dapat apat na iba-iba. Kaso ang side chain niya ay H atom ulit. Therefore, isa siyang achiral na amino acid. Moreover, take note that all amino acids in the human proteins are in L configuration, while those in the cell walls and antibiotics are in D configuration. Amino acids are substances that resist the drastic change in pH in a selected media or body compartment, making them a very good physiological buffer in the body. AAs can have a negative, zero, or positive charge depending on the pH of the aqueous environment. And an amino acid becomes no net charge or a deuterion at the isoelectric pH. Because they can accept or donate protons, amino acids can serve as buffers in aqueous solutions. Now, amino acids can be generally classified into three major groups: nonpolar amino acids, polar uncharged, and charged amino acids. If nonpolar ka, automatically guys, wala kang net charge. And if you are nonpolar, you are hydrophobic. Takot ka sa tubig. Therefore, you have a tendency to stay inside the interior of the protein. Kasi protein natin, baba din sa tubig. So, nonpolar amino acids tend to stay at the interior of the protein. And they form there inside hydrophobic interactions. We have the following nonpolar amino acids: glycine, alanine, valine, isoleucine, leucine, phenylalanine, tryptophan, methionine, and proline. Now, polar uncharged amino acids, they are polar, meaning they love water. They can be found at the surface of the protein, but they do not have any charge. Hindi sila positively charged, hindi sila negative charged. Therefore, they are not acidic and they're not basic in property. So, we have here the following depending on their predominant na functional groups. Yung mga may OH, we have serine, threonine, and tyrosine. SH for cysteine. Amides natin is asparagine and glutamine. Now, for charged amino acids, again, they are polar. Since charge is confers a polar property, but they can be either positively or negatively charged. Can be acidic or basic. And with that, they can form ionic interactions. Since they're polar, they can also be found at the surface of the protein. So if acidic ka, you have your aspartate or aspartic acid. You have glutamate, glutamic acid. If you're basic, you have your arginine, lysine, and histidine. Now, amino acids can also be abbreviated as one-letter abbreviation. Now, madali lang sila for most of them. Okay, kung ano yung first letter nila, yun na sila. Kaso in these following amino acids, they are abbreviated based on phonetically sounding letters. Like for example, arginine is R, kasi arginine siya. Asparagine is N, kasi asparagine. Aspartic acid is aspartic acid. In glutamic acid, it's glutamic acid. Phenylalanine, it's phenylalanine. Glutamine is cutamine. Tyrosine is tyrosine. And tryptophan is tryptophan. But lysine, oops, hindi siya L kasi it's for leucine. Lysine is K because it's the letter close to L. Now, isa-isahin natin yung ating mga amino acids. Glycine, as mentioned, is an achiral amino acid. And because of that, it also is the smallest side chain. Okay? Tapos, ang pinaka-function niya is 1. It's for heme synthesis. Kailangan siya doon. And siya ang ating major inhibitory neurotransmitter of the spinal cord. Ginagawa sila sa ating Rancho cells. And kaya tayo nagkakaroon ng spastic paralysis kasi with tetanus plasmin in tetanus, guys, piniprevent niya ang release ng glycine from these Rancho cells. Kaya nagkakaroon ng spasms causing spastic paralysis in tetanus. Alanine is a carrier of ammonia from the skeletal muscles to the liver, the site of ammonia disposal. Your valine, leucine, and isoleucine are accumulated in your MSUD due to the deficiency in enzyme branched-chain alpha-keto acid dehydrogenase. Phenylalanine, okay, is accumulated in phenylketonuria, having a mousy odor. the precursor siya rin ng ating tyrosine. So, in phenylketonuria, the deficient enzyme is phenylalanine hydroxylase. And as mentioned, guys, it's the precursor for tyrosine. Okay? Phenylalanine ka muna before ka maging tyrosine. And take note, guys, of the sequence of formation here. Pare, true love does not exist. Well, in some cases, for me, probably yes. Pero guys, dito tinan nyo pare, phenylalanine, true, tyrosine, dopa, L-dopa dapat to, may L dapat siya dyan guys, becomes dopamine, D, becoming norepinephrine and becoming epinephrine after. So, that is how you form your different neurotransmitters as well as your dopaminergic na transmitters. This is via your phenylalanine in your tyrosine. Okay? Tryptophan has the largest side chain and the precursor of your melatonin, serotonin, and your niacin. Pare, trip mo siya, no? Okay? Tryptophan, having your melatonin, serotonin, and your niacin. Okay? Tryptophan ang precursor ng mga yan. Methionine, the source of the metal groups on your metabolism, okay, mainly in the transferring of metal groups in S-adenosyl methionine. It's the precursor of your homocysteine and cysteine. And take note, guys, that homocysteine is important because it increases the risk of cardiovascular diseases. So if you have high levels of homocysteine in the blood, known as homocysteinemia, you have high risk for having cardiac events. Proline is not an amino acid but an amino acid. And because of its structure, it can interrupt alpha helices in globular proteins along with glycine. Okay, we have here naman your serine, threonine, and your tyrosine. They are containing of OH or hydroxyl group. And they can be sites of O-glycosylation of your proteins. Take note that thyroxine and melanin are derivatives of your tyrosine. As mentioned in your pare, true love does not exist. Okay? Sa part na yun, may pataas, di ba? Yung pataas na yun, yun yung ating thyroxine and melanin. Okay? Pero pag mahaba siya, tyrosine becomes L-dopa afterwards. Asparagine naman serves as a site of your N-glycosylation of proteins. Glutamine is also a carrier of nitrogen from peripheral tissue going to the liver, the site of ammonia disposal. Cysteine contains cis-sulfhydryl groups. And two cysteines connected by the sulfide bond is known as a cysteine. Keratin contains a lot of cysteine. Kaya people with curly hair have more cysteine. Therefore, kapag pinlansya mo siya, nadidisrupt yung ating mga disulfide linkages, straightening the hair in the process. Your aspartate and glutamate are acidic amino acids. Aspartic acid, glutamic acid. And they are very important for different neurotransmitter formations. One is that GABA and glutathione are derived from glutamate. And glutamate itself is already a neurotransmitter. It is the major excitatory neurotransmitter of the CNS, both brain and the spinal cord. GABA ang ating major inhibitory only for the brain. But as mentioned before, glycine is the major inhibitory neurotransmitter of the spinal cord. And now we have your basic amino acids. Histidine, arginine, and lysine. Histamine is derived from histidine. Creatinine, urea, and nitric oxide are all derived from arginine, while carnitine is derived from lysine. And it's very important because it allows the transfer of your long-chain fatty acids from the cytosol going to the mitochondria for beta oxidation. Now, in summary, these are the unique properties of your amino acids. Branched-chain amino acids, valine, leucine, isoleucine. The one that can disrupt your alpha helix structure, as mentioned, are your proline and glycine. Glycine has the smallest side chain. Tryptophan has the largest side chain. Arginine is the most basic amino acid, while aspartic acid is the most acidic amino acid. And take note of these concepts as before to us. Selenocysteine is known as the 21st amino acid, while pyrrolysine is the 22nd amino acid, mostly found in archaea organisms. Okay, usually they can be seen in extreme environments, but can also be seen in your gut microbiota. Now, these are important derivatives of your amino acids. You must know them. As mentioned guys a while ago, di ba? Pare true love does not exist. And as mentioned, thyroxine is the parent compound of thyroxine and melanin. Sila yung pataas sa ating sequence of events. Tryptophan becomes niacin, serotonin and melatonin. Pare, trip mo siya, no? Histidine becomes histamine. Glycine is important in heme synthesis. Glutamate can become GABA and glutathione. Arginine becomes creatine, urea, nitric oxide. Lysine becomes carnitine, and methionine becomes your homocysteine and cysteine. But you also have to know this, guys. Essentiality for amino acids. Essential means kailangan mo siya sa iyong human diet kasi hindi siya kayang gawin ng iyong katawan by itself. So we have here the mnemonic Private Team Hall always argues but never tires. So dyan guys, phenylalanine, valine, tryptophan, threonine, isoleucine, methionine, histidine, leucine, and lysine are all essential amino acids. But always argues okay, always arginine but never tyrosine. Now guys, ito guys, ang ano ba ang ating semi-essential amino acid? Ang ibig sabihin niyan is that kailangan mo lang siya on events kung saan meron kang increased growth or need of repair. For example, adolescence. Okay, hindi naman niya kailangan talaga ng arginine ng bata siya. Pero during rapid growth and development, you now need arginine. Therefore, it becomes a semi-essential amino acid. And during repair as well, kapag mayroon kang surgery, intense surgery, arginine also becomes a semi-essential. Mas kailangan mo siya in diet to replete your arginine stores for repair of the body. Now we head to the structures of your proteins. Primary structure, secondary structure, tertiary and quaternary structure. The primary structure is determined by the amino acid sequence itself. Okay, you read it from the N terminus. Okay, the first amino acid having the free amino group going to the C terminus. The other end kung saan it is the amino acid having the free carboxyl group. That is how you read your amino acid sequences. N terminus, C terminus. Para siyang amino acid. Take note that proteins here are bounded by a peptide bond. It is a partial double bond character protein in the trans configuration, very rigid and very planar, and can only be disrupted by hydrolysis. But it cannot be affected by denaturation. Primary structure is the only structure of protein that is not affected by denaturation. More on that later. In secondary structure, these are stabilized by hydrogen bonding and can form two major structures. An alpha helix, most commonly seen in keratin and hemoglobin, and beta sheets, wherein they are seen in amyloid and immunoglobulin structures. Okay, they're only formed or stabilized by hydrogen bonding. But in a tertiary structure, you form a three-dimensional shape of a protein. Initially, flat ka lang, di ba? Pero this time, nagiging 3D ka na. This is because of your disulfide bonding, hydrophobic interactions, hydrogen bonds again, and of course, ionic interactions. Now, kapag ang mga tertiary structures na yan ay nagsama-sama into bigger structures, that is a quaternary structure. For example, your hemoglobin. It is composed of 4 polypeptides combined together, forming a new molecule. Okay, that is how it works. So, it's a quaternary structure of 4 different tertiary structures. Now, protein folding is very important because your amino acid sequences become functional after they change their property depending on their folding. So, pag nabago ng fold yan, they can differ also in function. So, there are actually proteins specialized for proper folding. These are known as chaperones. They prevent aggregation and misfolding in the process. Now, in denaturation, as mentioned a while ago, it is due to the unfolding and disorganization of the protein, pero wala kang hydrolysis. Therefore, the primary structure is maintained. There is no destruction of your peptide bonds. And they're mainly done by your denaturing agents. Okay? They may be reversible, but most proteins are permanently disordered after denaturation. Again, guys, primary structure is the only form of protein sequence not affected by denaturation. Now, here are some protein folding disorders of importance. One is your prion diseases, the one causing your spongiform encephalopathy. Ito yung mga Kuru, ito yung mga Creutzfeldt-Jakob disease. Now, the pathogenesis here is that there is an accumulation of prion-related protein beta-plated sheets. Normally kasi, yung ating PRPC, the normal prion protein, is an alpha helix structure and is labeled to proteases and chemicals. Pero, when it becomes mutated due to proper infolding, nagiging siyang PRPSC. That is the abnormal protein of prion and it is in the beta-plated form. Diba? Nagbago agad siya ng kanyang function. From an alpha helix na label to proteases, this time, as a beta-plated form, it's now resistant to proteases and chemicals. That's very dangerous. Another one is your Alzheimer's disease. Okay, a very testable disorder in the board exams. It is the most common, most important degenerative disease of the brain. And ang problema sa kanya is that you have the accumulation of your senile plaques and neurofibrillary tangles containing aggregates of beta amyloid. Okay, so this is very dangerous as well. And take note guys, okay, ito baka sa pato, or baka sa IM, or baka even in biochem, take note that ApoE is implicated as a potential mediator for this conformation transformation. Kasi dito guys, having a beta amyloid structure, nagiging siyang resistant to proteases and different chemicals, making it more resistant and making it to be stored in the brain, causing degeneration for your Alzheimer's disease. Now guys, you also have here the signaling of your different amino acids. In the N-terminus, it contains the targeting signals. It makes sense, di ba? If you want to transport your molecule from one compartment to another, you have to attach a targeting signal. Parang siya yung ating leader, okay? Kung saan magdidirect siya sa ating mga amino acid sequence kung saan pupunta. It is found therefore sa pinakaunahan, sa ating N-terminus. Now, if you want to allow your amino acid to stay in a certain area of the cell or body, you should have retention signals. And they're mainly found at the C-terminus of your amino acid sequence. Now, proteins are of two different structures, globular and fibrous. Globular, from the name itself, spherical siya. And having this spherical structure allows it to be soluble in water. However, fibrous protein, meaning elongated, mahaba sila, they're less soluble. Therefore, mas maganda sila for structure of your body. Like for example, collagen fibers, diba? Mga fibers sila. So, para sa scaffold ng ating katawan, they are structural proteins. While globular proteins are spherical. Mas sila ang ating mga naka-dissolve sila sa ating blood, for example. Yung ating mga hemoglobin, myoglobin, albumin, globulin, di ba? While our fibrous our fibrous proteins are collagen fibers, keratin. So, they are more for structure. Now, let's have first our attention on our globular proteins, for examples, mainly our myoglobin and your hemoglobin. So, a myoglobin is only a tertiary protein, but a hemoglobin, as mentioned, is a quaternary protein because it has 4 polypeptide structures. Myoglobin can only bind 1 oxygen, while hemoglobin can bind 4 molecules of oxygen. Myoglobin is in the hyperbolic state kapag nag-dissociate siya with oxygen. Okay? Pero with our hemoglobin, it is in the sigmoidal structure kasi it has cooperativity. Bakit? Ang point niyan kasi, when you attach oxygen to hemoglobin, that oxyhemoglobin with only 1 oxygen is has a more affinity to more oxygen. So meaning, the more oxygen na nagkakaroon siya, the more tumataas ang kanyang affinity for more oxygen. And that explains the sigmoidal structure of its oxygen dissociation curve. It allows a point for control. So, ang mangyari dyan guys, remember here the different points for control for release of oxygen and storage of oxygen with your hemoglobin. Okay, remember the mnemonic of Doc Broly. Kabet, do the right thing, let go. Okay, so more on that in future guys, ha? And with that said guys, myoglobin is more for storage of oxygen, but hemoglobin naman is more for transport in the blood. Now, more on hemoglobin, we have two forms here. The T form, the taut form, and the R form, and the relaxed form. Guys, the relaxed form has a higher affinity for oxygen. It kind of makes sense. Relaxed form kay. So, para relax, you're more huggable, di ba? Pero pag stress ka, taut form ka, ay, wala akong pakialam sa'yo, bahala ka sa buhay mo. You have a lower affinity for oxygen. Okay? Now, hemoglobin requires 2 glycine and 2 succinyl-CoA molecules to form 1 pyrrole. And 1 pyrrole must combine to 3 other pyrroles to form your protoporphyrin 9. And must be combined with the ferrous iron, guys ferrous iron siya, to form heme. So, heme is formed already. Now, heme must bind to polypeptide to form 1 hemoglobin chain. And depending on the number of chains, okay, you will have your hemoglobin. Okay, 2 alpha chains and 2 beta chains will form your hemoglobin A. Now, for the different terminologies of your hemoglobin, look at your handout for that part. Okay? Basta guys, ang alam nyo guys, glycine is the parent compound of your heme molecules. Now, as mentioned guys, your protoporphyrin 9 is a porphyrin. And it's formed by 4 aromatic pyrrole rings by a methine bridge or metanyl bridge. And it emits a strong red fluorescence with a maximum absorption spectrum of 400 nanometer known as the sorbet peak. Take note that heme is a metalloporphyrin. It's a porphyrin having an iron at the center. At dapat naka-ferrous iron siya or Fe2+ to allow oxygen to be attached to it. Pag ang iron state niya ay ferric 3+, hindi makakabind ang oxygen sa kanya. Now we head to our fibrous protein and mainly about our collagen. Collagen is the most abundant protein in the body and it confers a tensile strength. So it is composed of 3 polypeptides wound around in a triple helix formation. So there are at least 28 types but the most common is our type 1 collagen fiber. Now, collagen fibers have a sequence very unique to it. Glycine, proline, and hydroxyproline and hydroxylysine at the Y position. So, GXY position siya parate. So, take note of this concept. Now, collagen can be synthesized in 2 compartments of the body. One at the level of the rough endoplasmic reticulum, while the rest will be done at the extracellular fluid. Okay? So, doon siya nangyayari. The first step is the formation of your pre-pro-collagen. Okay? And it contains your pro-alpha chain containing your GlyXY amino acid sequence. Eventually, it will be hydroxylated with vitamin C, ferrous iron, guys, oxygen, and your alpha ketoglutarate. These molecules are capable of hydroxylizing your proline and lysine residues. Sila lang po ang nagkakaroon ng hydroxylation, forming your pro-collagen. Now, this pro-collagen, before forming a triple helix, must first be glycosylated at the level of your hydroxylysine. Okay? With that, you will have your triple helix formation. And this will now be exocytosed into the extracellular fluid. Na mangyari dyan, nagkakaroon ka ng proteolytic processing. The pro-collagen will now become your tropocollagen after the removal of the C and N terminals, as you can see here. But the tropocollagen can only become a mature collagen fiber when they are cross-linked with each other via your lysyl oxidase. And kailangan mo ng copper para mabuo ang ating collagen fiber. So having copper deficiency can lead to faulty collagen formation. Take note guys the following conditions of importance here. In scurvy, you have a problem of the hydroxylation step. So, dyan guys, as mentioned, vitamin C is very important and dapat meron kang ferrous na iron. It is also the rationale why you will have impaired healing kapag meron kang poor oxygenation for tissues. Kasi, kailangan mo ang oxygen para magkaroon ka ng proper hydroxylation step. If you have carbon dioxide in the process, hindi ka magkakaroon ng proper healing of your wound processes. Okay? In OI or osteogenesis imperfecta, ito yung magkakaroon ng brittle bone and having a blue sclera. Okay? So dito guys, magkakaroon ka ng problem here sa ating formation ng triple helix formation. Now, as mentioned guys in the review prior for the diagnostic exam, copper deficiency seen in Menkes disease can lead to the problem in cross-linking stem. Now, collagen fibers are very important. They're the most predominant protein in the body. Okay, ang kanyang pinakamarami is your type 1. And type 1 is the one seen in bones. Okay? So, kita yan sa ating mga osteogenesis imperfecta patients. Siya pinaka-problema dyan. Type 2 is mainly seen in the cartilages. Okay, if you have achondrogenesis, you have a problem of your type 2 collagen. If you have your reticulin fibers, those are your type 3. They are found in blood vessels and granulation tissue. And they are mainly found as a defect of your Ehlers-Danlos syndrome, vascular type. Now, before heading to the other types, take note that collagen formation is important in wound healing. Now, for the first part of wound healing, ang pinakamarami dyan is your reticulin fibers or type 3. They are found in your granulation tissue. Now, as you remodel your tissue over time during repair, nagiging siyang type 1 collagen. Kasi type 1 collagen is stronger in structure. So, siya yung magiging permanent afterwards. So, pag the early wound healing ka, ang predominant na tissue ay type 3. Pero pag later wound healing ka na, ang predominant ay type 1 after. Type 4, think of the 4 on the floor mnemonic, the basement membrane. And take note of processes involved with basement membrane problems. Alport syndrome, a genetic problem, kung saan meron kang gross hematuria, and meron kang familial na bilateral hearing loss. In good posture syndrome naman, you have anti-GBM, antibodies, which are autoantibodies attacking the basement membrane of your lungs and your kidneys. So, meron kang hematuria, meron ka ring pulmonary hemorrhage or hemoptysis. Type 5, bone, skin, fetal tissue, and placenta. So, medyo minor lang sila and can be seen as a defect of your classic type of your Ehlers-Danlos syndrome. While 7 are anchoring fibrils. Okay, they are found at the level of the basement membrane. Attachment sila ng ating basal cells, epithelial cells, to the basement membrane. So, para silang hook, para siyang number 7, para siyang hook, di ba? So, anchoring fibrils are like hooks representing your type 7 collagen. And problems in dystrophic epidermolysis bullosa is a problem for type 7 collagen fiber. Now, we head to your elastin. Elastin fibers are not collagen fibers, okay? But they're very important because they confer elasticity. They have rubber-like properties, meaning pag stretch mo siya after, it will go back to its original shape. Now, it contains the following amino acids, proline and lysine. Minimal lang po yung ating mga hydroxyproline at hydroxylysine. But take note guys, dito yung kanyang scaffold pag bumubuo sila. They need a scaffold para magkaroon ka ng elastin fiber, known as your fibrillin. And that fibrillin is the one defective in your Marfan syndrome. Okay? Unlike in your collagen fiber, you don't have any scaffold. Wala kang fibrillin for collagen fibers. And of course, desmosine is the one that cross-links the precursor tropoelastins together, forming the mature elastin fibers. Immunoglobulins are oligomeric glycoproteins. Okay? They are mainly produced by the plasma cells, and they have two unique chains. You have two heavy chains and two light chains. Two heavy chains determine the major isotype of the Ig classification. Alpha, delta, epsilon, gamma, mu. Alpha, IgA, delta, IgD, epsilon, IgE, gamma, IgE, and mu, IgM. Now, key points in the structure. The Fab region here, the Fab, means antigen binding site, while the FC, which actually means crystallizable site, is found here. The hinge is at the center and has a flexible area siya containing sulfur bonding. Take note of that. It has sulfur bonding. Now, your immunoglobulin can be digested into different structures depending on the enzyme being used. When you use pepsin, guys, hinati mo lang siya sa gitna. You form here one Fab and one FC here. Okay? Okay? One Fab and one FC here. But in papain, you divide it into three structures. 1, 2, 3. So you have here one FAB, another FAB, and one FC structure. So papain, 3 parts, pepsin, 2 parts. Take note as well the two structures involved here in your complex formation of your antigen and antibodies interaction. Your immune complexes, di ba? So your epitope and paratope. Epitope is the part of the antigen, yung E is part of the antigen, while the paratope is part of the antibody. This is the paratope, this is the epitope of your immune complex formation. And that is all for your protein structures. Now we head to your carbohydrates. Again, carbohydrates are the most abundant organic molecules in nature. And they represent an empiric formula of 1 carbon is to 1 water molecule. Hence the term carbohydrates. So here guys, the N serves as the number of carbon atoms. So if you have 3 carbons, you have 3 water molecules in a carbohydrate molecule. Now, carbohydrates can be classified based on the linking of their sugar units. They are linked together via your glycosidic bonding. A monosaccharide is your 1 sugar unit and serve as the building block of all carbohydrates. Disaccharides are 2 sugar units. Oligosaccharides are 3 to 10 sugar units. Take note guys 3 to 10 ang ginagamit natin for your oligosaccharides. And polysaccharides are more than 10 sugar units in the process. Now, you can classify your monosaccharides depending on the number of carbon atoms present. So, if you have 3 ka, trioses ka, 4 tetroses, 5 pentoses, and so on. And take note as well that monosaccharides can also be classified based on their functional group. They can be aldoses, having an aldehyde group, or ketoses if they have a keto group present. And these are your clinically important hexoses. So hexoses meaning the monosaccharide has 6 carbon atoms. Of course, we have here the representative molecule, glucose, the major fuel for the brain, renal medulla, cornea, retina, testis, and the RBC. It is the most predominant sugar in the human body and is the universal fuel of the fetus. Fructose are found mainly in fruit juices, and both galactose and mannose are found in glycolipids and glycoproteins. Next, we head to the clinically important pentoses. These are monosaccharides having 5 carbon atoms per sugar unit. Ribose serve as the component of nucleic acids and coenzymes. And removal of the hydroxyl group at the carbon 2 yields a deoxyribose structure. Ribulose is an intermediate product in the pentose phosphate pathway. And in patients having essential pentosuria, meaning you are urinating pentose units, the major pentose there is your cellulose pentose. Okay? You also have your clinically important disaccharides. Disaccharides is the combination of 2 monosaccharides or 2 sugar units. Sucrose is formed from glucose plus fructose. Lactose is formed between glucose and galactose. And maltose is formed between 2 glucose units. Take note that lactose, even if it is a disaccharide, may be excreted in the urine in pregnancy. Okay. Now we head to your polysaccharides. Wherein there are more than 10 sugar units rather. More than 10 sugar units. So the storage polysaccharide in animals is termed as your glycogen. And it has two kinds of linkages. Alpha 1 to 4 for the linear part. Pero kapag liliko siya to form a branch, ang tawag naman dyan ay alpha 1 to 6 linked already. So kung meron kong mga king or linking na pa-branch, therefore, glycogen is actually an insoluble polysaccharide. It does not dissolve in fluid. While in starch, sa ating plants, meron siyang dalawang components, amylopectin and amylose. Amylopectin is the one that is branch. It has both 1 to 4 linkage and 1 to 6 linkage. Same with glycogen. But 20% of starch is in amylose, meaning soluble siya and unbranched kasi it only has a 1 to 4 linkage. Now, we also have other polysaccharides. Cellulose is the chief constituent of the plant cell walls. Inulin is a polysaccharide of fructose. And inulin is actually a good substance for determining the EGFR of patients. Chitin is a chief constituent of the fungal cell walls and part of the exoskeleton of insects and crustaceans. Now we head to this property known as reducing sugars. Sugars can become reducing agents if they have a free functional group, either an aldehyde or ketose group. And they can be identified using the Benedict's test. So dyan guys, automatically, all monosaccharides are reducing sugars because they have a free functional group. Pero pag usapan ay disaccharides, only lactose or maltose are reducing sugars. Sucrose and trehalose are non-reducing sugars. Okay? Doc, what is trehalose? Trehalose is the sugar of your insect hemolymph. Now, let's talk about isomers. Isomers refers to compounds having the same chemical formula. So, they can be trioses of different structures, pero pare-pareho sila ng ating empiric chemical formula. They still follow this formula of 1:1 na carbon and water. Now, for the first type of isomers, we have your epimers. Epimers are isomers that differ only in configuration around only a specific carbon atom, except for the carbonyl atom. Doc, what is the carbonyl atom? The carbonyl atom is the carbon double-banded to oxygen atoms. Okay, so dito, any carbon atom, not the carbonyl carbon, ang involved sa ating epimerization. So for glucose, guys, the second epimer is known as the mannose. Kasi it has 2N. The third epimer is your allose kasi all is well. Okay, think of the Three Idiots. All is well. Okay, my favorite movie. One of my favorite movies of all time. And fourth epimer is your glucose. Gala ka ng gala. Lakwatsa ka ng lakwatsa. Kwartsa. Okay, fourth epimer of glucose. Okay? Enantiomers naman are stereo isomers or optical isomers. They are structures that are mirror images of each other. They can be D sugars or L sugars. Now, D sugars po ang ating pinaka-common sa ating mga sugars. They're mostly D configuration in the human body. But in proteins, as mentioned before, they're mostly in the L amino acids. Okay. Now, let's head to anomers. For that, let's talk about cyclic structures. Cyclic structures are very prominent among your monosaccharides, those in aqueous solution. Okay, they can be a furanose or a 5-membered ring, or a pyranose in a 6-membered ring. Now, if there's a rotation around the carbonyl atom, as mentioned, the one with double bonding to an oxygen, you can have here an anomerization. And it can be an alpha form or beta form. Now, to interconvert between the alpha to beta or beta to the alpha, ang tawag dyan ay mutarotation. And it occurs without energy expenditure. In contrast, when you perform enantiomerization and epimerization, kailangan mo ng energy. But in anomerization, hindi mo kailangan ng energy. Now, to summarize, isomers or molecules having the same chemical formula. Okay, but they can differ in structure. In epimers, they have different configuration around one specific carbon atom, except the carbonyl atom. Anomers differ around the carbonyl atom, while enantiomers naman are mirror images of each other. And lastly, let's talk about how glucose are transported across the body. Okay, we have the different GLUT transporters. GLUTs 1 to 5 are facilitated diffusion, while SGLT1 or 2 are secondary active transport. Now, for memorization, guys, take note of these mnemonics. GLUT2, think of the number 2. Beta cells, beta is the second letter of the Greek alphabet. You have 2 kidneys, you have 2 liver lobes. And the GI tract, GI has 2 letters. So, GLUT2 yan. Tapos, ang ating GLUT4 is the one that is insulin dependent. The rest are insulin independent. And GLUT4 are only found in adipose tissue and striated muscles, which are your cardiac muscles and skeletal muscles. GLUT5, 5 for fructose. Okay? So, fructose for absorption of the GI tract and for the sperms as well, since fructose is the energy of sperm motility. Take note that GLUT5 is mainly found at the lumen because there are 5 letters in lumen. While GLUT2 are found at the basement membrane of your intestines because basement membrane has 2 words. And that is all for your carbohydrate structures. Now we head to your lipid structures. Now, your lipids are different from your previous compounds. Okay? Diba, kanina, amino acids, they are the monomers of your proteins. Tapos, monosaccharides or sugar units are the building blocks of your carbohydrates. Now, lipids, wala tayong tinatawag na polymerization. Wala kang building block. Lipids are, in general, insoluble in water. Okay, soluble in non-polar organic solvents, such as ether and chloroform. They are not chemically related with each other, but they are only physically related. Lahat sila ay hydrophobic in nature. That is their major similarities. They are not true polymers. Now, one of them is your fatty acids. Fatty acids are carboxylic acids with a long aliphatic hydrocarbon chain. Now, meron kang dalawang area dyan of concern. A hydrophobic chain and a chain that is hydrophilic. Yan lang ang nag-interact sa water. Ito naman ay nag-interact with a non-polar substance. So, the longer the aliphatic hydrocarbon chain, the more it becomes hydrophobic. Ganun ang ating mga fatty acids. They can be classified depending on length, presence of double bonds, and number of double bonds present. Short chain ka pag C2 to C6 ka, medium ang C8 to C14, and non-chain ka pag at least C16 ka. Pero pag at least C22 ka, very long chain fatty acids na ang term sa'yo already. Okay? They're very important because kapag nagkakaroon ka ng absorption, ang fate nila will depend on their length. Kasi pag long chain fatty acids ka, you are only transported in kilomicrons. But both short chain and medium chain fatty acids can be directly absorbed in the bloodstream, going to the hepatic portal vein in the process. Now, kailangan din ang ating short chain fatty acids kasi they are actually food for your colonocytes. Okay? So, sa mga tao na mayroong problems with surgery, for example, nagre-recover pa yung intestines mo, you may provide short chain fatty acids in a diet na nakalagay sa ating parenteral nutrition, sa ating blood, para mabigay yung ating colon, para sila ay magkaroon ng trophic improvement, para mag-grow ng ating colonocytes. With that said, kahit na fatty acid siya, it can still be soluble in water. So, yun yung importance niya. Kasi the more na mas mahaba yung kanyang hydrophobic chain, the more na siya ay magiging hydrophobic in nature. As mentioned, fatty acids can be also classified depending on their double bonding. Now, kapag wala kang double bond na makikita, ang tawag sa iyo ay saturated na fatty acid. Kasi you're saturated with hydrogen atoms for the whole chain. Okay, meaning all carbon to carbon bonding are single bonding. Now, if you are unsaturated fatty acid, you must have at least one double bonding in the hydrocarbon chain. Okay, and they can be classified as a cis form or a trans form. Okay? Ang ating mga UFA can become a cis form or trans form. Pag the H atoms are on the same side, think of two sisters holding hands. Okay? Cis form siya. When the H atoms are found on the opposite side, think of a trans form. As you can see here guys, in your saturated fatty acid, there are no double bonding. They're all saturated with hydrogen atoms, the one in color blue. Now, kapag nagkaroon ka ng double bonding ka dito, magkakaroon ka ng unsaturation, meaning nabawasan ka ng hydrogen bond in the process. Dahil ang H atoms na natitira are both on the opposite sides, ang tawag sa kanya ay trans na fatty acid. But if they're on the same side, they form a bent configuration, they are in the cis position. Now, kailangan din ang ating number of double bonding. If you only have one double bond, ang tawag sa kayo ay MUFA or monounsaturated fatty acid. If more than one double bond ka, you have your polyunsaturated fatty acid or a PUFA. Okay? As you can see guys dito, ito ay saturated na fatty acid. Ito ay unsaturated, pero dahil isa lang ang kanyang double bonding, ang tawag sa kanya ay MUFA. Pero dito, you have more than one bond already na double bond. Kaya ang tawag sa iyo ay PUFA already. So, siya ang PUFA. Now, dito guys, essentiality. As mentioned, kapag essential ka, kailangan ka sa iyong diet. Same in this case. Kasi dito, humans lack the enzymes capable of introduction of double bonding beyond the 9 carbon. Therefore, linoleic acid, alpha-linolenic acid, and arachidonic acid are all essential fatty acids. But take note that arachidonic is only semi-essential kasi it can be derived from your linoleic acid. Now, as discussed in my diagnostic exam, my mnemonic here is that linolenic acid, the one with N, is not the parent compound of your arachidonic acid. Now, bakit sila essential? Kasi they're actually integral components of the membrane structure, pero hindi sila kayang gawin ng ating katawan. And kailangan ng ating mga fatty acids na to for the formation of your arachidonic acid, mainly your linoleic acid. As you can see here guys, they're also having an omega bonding nomenclature para sila ay mas mabuting maintindihan. So, paano ba ang ating omega bonding? So, omega carbon is the one at the very end. Okay? Now, you check the bonding after the omega carbon here. One bond, second bond, third bond. Pag may nakita ka siyang double bond, that means siya ay naka-omega 3 na bonding. Omega 3 bonding yan. Kasi nga, carbon mo to na omega 1, 2, 3. The third bonding from the omega carbon has a double bond. Kaya siya omega 3. And take note guys that your alpha-linolenic acid along with your timnodonic acid and cervonic acid are all omega 3 series fatty acids. While your linoleic acid, the parent compound of your arachidonic acid, are the omega 6 series. And take note that the omega 3 series are very important kasi they are actually more favorable kasi they can actually decrease serum triglyceride levels and can produce lower thromboxane. As mentioned a while ago, omega 3 ang ating alpha-linolenic acid. Pero ang ating arachidonic acid and linoleic acid are both omega 6. And arachidonic acid is the parent compound of one of the strongest eicosanoid causing platelet aggregation, thromboxane. So, mas gusto mo na ang makain mo ay more omega 3 than omega 6. Both are important, both are essential, pero kailangan mas maraming ang ating omega 3 para konti ang ating thromboxane sa ating katawan since it is part of the omega 6 series. Now, lipids in general can be classified as fats, oils, and waxes under simple lipids, phospholipids, glycolipids, lipoproteins, sulfolipids, and aminolipids, all under complex lipids. And the rest are precursors and derived lipids. Now, simple lipids are esters of fatty acid plus a glycerol. So, yan ang kanilang formula dito. While complex lipids are esters of fatty acid with an alcohol, which can be a glycerol or sphingosine, plus additional groups, which can be a phosphoric acid, which can be carbohydrates or even proteins. Now, triacylglycerol is the main storage form of lipids in the body and mainly stored in adipose tissue. They're also termed as neutral fat or triglyceride and have the following structure. Kasi triacylglycerol, you have three fatty acids combined to a glycerol substance. Lipoproteins are spherical macromolecular complexes of lipids and proteins. Okay? They have a core, that's a core, and a shell. The core contains neutral lipids since they are hydrophobic. So, bawal sila ma-expose sa water. But the shell contains amphipathic lipids. Now, amphipathic means meron kang part na hydrophobic, the one interacting with the core of your lipoprotein, while the hydrophilic area is the one exposed to water. So, siya ang bubuo ng ating shell. Take note that apolipoprotein only refers to the protein. Pero pag nalagyan siya ng lipid element, saka siya nagiging lipoprotein. Okay? Take note of this concept. Now, here are important lipoproteins, but more on this under Dr. Baticulan's lecture. What I would like you to learn here is that there are different properties. Chylomicron yung pinakamalaki sa lahat and has the lowest density. So, when you put it in water, siya yung pupuna sa pinakataas. And it has the highest TAG content. LDL has the highest cholesterol content, while HDL has the HDL has the highest protein content. Now, cholesterol is a very important structure in animal tissues. It's a steroid structure having a 27-carbon compound with 4 fused hydrocarbon rings, A, B, C, and D. Pag nakastore siya, ang tawag ay cholesterol ester kasi it must be bounded to a fatty acid for storage. But take note, guys, that the major route of elimination of cholesterol is via bile excretion. Kaya if you are fond of eating lots of cholesterol, you are actually bound for having gallstone in the future. Now, cholesterol can be derived into different hormones in the body. Kaya sila very important. Now, if you want to form sex hormones and adrenal hormones, kailangan mo yung ating rate-limiting step na cholesterol desmolase, also known as your side chain cleavage cytochrome P450 enzyme. While for the vitamin D, pwede siya ma-derive from your 7-dihydrocholesterol in your skin. Take note, guys, that cholesterol can only be eliminated via formation of your bile acids na pupunta sa ating bile excretory going to our poo-poo. The rate limiting step there is your 7-alpha-hydroxylase. Okay? And kapag nag-affect siya sa cholesterol, it will make your two primary bile acids. The cholic acid and your quinodeoxycholic acid. Both are C and both are found, or rather, both are formed by the liver. Among them, the most abundant or the more abundant is your cholic acid. Now, these bile acids can be degraded by the bacteria found in the colon. Cholic acid becomes deoxycholic acid, and quinodeoxycholic acid becomes your litocholic acid. Eventually, they can be conjugated to taurine and glycine, forming bile salts in the process. Bakit ba sila mahalaga? They are important for emulsification of fat. Among the different bile acids, the most toxic is your litocholic acid. So, kailangan mo talaga siyang ma-excrete sa ating katawan. And that's all for our lipid structures. Now we head to your nucleotides. Now, it is important to distinguish the different components of your nucleotides. So, as you can see here, guys, a nucleotide contains a base, a sugar, and a phosphate. The one with T is nucleotide. But a nucleoside only have a base and a sugar. S for nucleoside. So let's go first to our base. The base refers to the nitrogen-containing cyclic structures. They are purines and pyrimidines. Okay, we have 4 major purines in the body and 2 major pyrimidines. However, among purines, only adenine and guanine participate in nucleic acid formation. Xanthine and hypoxanthine are intermediates of purine metabolism. Now, we have actually 3 major pyrimidines rather. Cytosine, uracil, and thymine. Okay, take note of these components. Now, puga, purines, guanine, and adenine. While cut the pie, we have here pyrimidines, cytosine, uracil, and thymine. Okay? Now, for bases, as you can see guys, both A and G are DNA and RNA purines. Pero pag ang usapan ay RNA pyrimidines, we only have C and U. Pero pag ang usapan ay DNA pyrimidines, we only have cytosine and thymine. Point is, cytosine exists in both RNA and DNA, but uracil is only found in the RNA, while thymine is only found in DNA molecules. Take note the structure of the purine ring. The purine ring can be derived from glycine, carbon dioxide, aspartic acid, glutamine, and your N10-formyl tetrahydrofolate. So guys, 3 carbons come from the following. Dalawa from the N-formyl THF, 1 from carbon dioxide. 3 N's come from glutamine and aspartate. 2 from glutamine, 1 from aspartate. Tapos the rest are from glycine, which composed of 1 N and 2 C's as a whole structure. In contrast, mas simple ang ating pyrimidines, okay? You only have your aspartate, carbon dioxide, and the amide nitrogen of the R group of the glutamine. Now, let's head to the sugar. The sugar differ depending on the nucleotide. Pag RNA, D-ribose sugar siya. There's actually a process here wherein kapag tanggalan ka ng OH sa ating carbon 2 of D-ribose, magiging kang deoxyribose. And this deoxyribose is the one predominant in your DNA. Alright? Now, when you combine a base to the sugar, you form here a nucleoside. Okay? Nucleoside ka kapag sugar and base ka lang. Tapos guys, take note na meron akong tinatawag na N-glycosidic bonding between the base and the sugar itself. You have the N-glycosidic bonding. But when you add a phosphate to the existing nucleoside, you now form your whole nucleotide structure. Again, you may T guys, phosphate, nucleotide. Again, for review, the base combines with the pentose sugar via a non-glycosidic bond. The pentose sugar binds with the phosphate via an ester bond. Ester bond siya guys dito. Pero the different succeeding phosphates of phosphate to phosphate will form an anhydride bonding with each other. Okay? So guys, again review, base to sugar and glycosidic bond. Sugar to phosphate, you form your ester bond. Phosphate to phosphate, anhydride bonding. Now, nucleic acids are polymers of nucleotides, joined by 3 to 5 phosphodiester bonding. You have here the DNA and RNA. In general, they are polyfunctional acids, negatively charged in physiologic pH, and absorbs light at 260 nanometers at pH of 7.0. And you write them in a base sequence, dapat 5 end ka to the 3 end. That's how you write them or read them. DNA is found mainly in the nucleus, while RNA in the cytoplasm. As mentioned guys, deoxyribose is the predominant sugar in DNA, while ribose naman is the parent sugar for your RNA. Tapos double-stranded si DNA most of the time, while single-stranded naman si RNA natin. Now, Sir James Watson and Francis Crick, plus Rosalind Franklin, are the 3 scientists who work together on studying the DNA structure of man. And they have developed the Watson-Crick model. Now, ang point niyan din is one, when the DNA is viewed along its axis. Sapo, DNA yan, di ba? When you look at the axis, the orientation of the strands turn clockwise or right-handed. That's one. And we have the base pairing rule and hydrogen bonding. Ang point niyan, all adenine binds to thymine and all guanine binds to cytosine. And take note that G and C bonding are stronger than A to T bonding because they are difficult to be destroyed. A higher GC content in a DNA sample yields a higher melting temperature. It means more temperature is needed para ma-destroy ang ating DNA bonding. For my own personal mnemonic, guys, GC couples flock at the library, and GC couples are stronger together because they help each other out to have higher grades. Two strands are anti-parallel to each other. One strand runs in the 5 to 3 direction, while the other at the 3 to 5 direction. And the grooves of the DNA serve as sites of DNA-protein interaction, affecting gene expression. Lastly, we have your Chargaff's rule, which tells us that the number of purines is equal to the number of pyrimidines. So, if the sample of DNA has 23% adenine, what will be the amount of guanine present? As mentioned, guys, we have A to T binding, and you have your Chargaff's rules. Therefore, if you have 23% adenine, you also have 23% thymine. When you combine them together, you form around 56%. And when you subtract their content from the 100% sample, you will have 54% G and C. And as mentioned, G and C are always in pair. Therefore, when you half them, you will have 27% G and C. Therefore, the answer here is actually 27% guanine. There are actually 6 types identified so far, but 3 are very prominent. And among them, the most important is your B-DNA, the most common form physiologically. Both A and B DNA are right-handed, but Z DNA is left-handed and is seen mostly in the 5 ends of your chromosomes. Now, DNA are organized mainly by your most abundant chromatin protein, which are your histone proteins, which are rich in arginine and lysine. They have 2 types, core histones and linker histones. In general, they are actually basic in structure, while DNA is acidic in structure. Kaya sila merong interaction. Mas base si ating histone proteins kasi they are rich in arginine and lysine. And they form core histones and linker histones. Linker histones is represented by H1 and is only seen in the linker region. While core histones can form an octamer composed of pairs of H2A, H2B, H3, and H4. H3 and H4 are rich in lysine, while H2A and H2B are rich in arginine. Now, kailangan sila kasi DNA of humans are very long. So, para mag-pack sila inside the small nucleus, you have to have your histone proteins. Now, levels of DNA organization are as follows. 1, they can be a DNA double helix. They can be compacted via a 10 nanometer chromatin fibril, 30 nanometer chromatin fibril, a supercoiled structure or a chromosome structure. The first level is having a 2 nanometer DNA double helix. That is the base structure of your DNA. Now, kapag nagkaroon ka ng beads on a string appearance on electron microscopy, you have here now your nucleosome structure, which is this one, plus a linker DNA. Ang tawag sa'yo ngayon ay 10 nanometer chromatin fibril. Pero if you have a group of nucleosomes already, together, you form a 30 nanometer DNA chromatin fibril, also known as a solenoid. Now, you can also have here a supercoiling structure, which further promotes packing of DNA into compact structures. Now, DNA can also exist in chromosomes, especially at the time wherein you are undergoing mitosis and meiosis. You have 23 pairs of chromosomes, 22 of them are autosomes, while you have a single pair of sex chromosomes, your X and Y. And under your electron microscopy, you can see a differentiation in terms of the histochemical structure of your euchromatin and heterochromatin. Euchromatin are those that are less condensed. They are more white in structure or pale. Kasi they are actually transcriptionally active. Therefore, they should be more loose para mas madali sila mag-cause ng expression. Hence, they stain less densely. On the other hand, yung mga naka-H, heterochromatin are highly condensed. Kasi they are actually transcriptionally inactive. Hindi nila kailangan mag-participate with other substances for expression. Hence, they're not being used. So that, because of that, kailangan mo silang itago into compact structures. Now, RNA, I will only discuss here the salient points of these substances because they are further discussed in genetics. Now, there are of two types. Protein coding RNA being represented by your mRNA and non-protein coding RNA for the rest. Among them, mRNA is the most heterogeneous in structure kasi it functions as a messenger conveying information from the DNA to the translation machinery, which are your ribosomes. Sinasabi niya if kung ano ang dapat na i-form na amino acid sequence, which can differ depending on the protein being made. Now, your rRNA is the most abundant and are the ones responsible for formation of your amino acid sequences. While transfer RNAs, they transfer amino acids from the cytoplasm going to the ribosomes during translation. And ang kakaiba sa kanila is that they contain significant amounts of unusual bases, mga pseudouridines, inosines, etc. While the rest are all involved in gene expression regulation. Your SNRNA, MIRNA, SIRNA, and your LNC RNA. And that's all about the structures of your macromolecules. Now we head to your nutrition. So what is nutrition? Nutrition refers to the science of foods and their substances they contain, their actions, interaction, and balance in relation to disease. Basically, pinag-usapan dyan ang action to the body, interactions with each other, and their balance with respect to health and disease. Now, for some definition of terms, nutritional status refers to the condition of the body in relation with nutrition. Malnutrition can be either undernutrition, kung saan meron kang deficiencies in some nutrients, while overnutrition refers to excesses in some nutrients. Ang usual misconception dyan ay malnutrition only refers to undernutrition. That is false. Overnutrition, such as obesity, is still under malnutrition. Recall the etymology of the malnutrition term. Mal means bad, meaning pangit or deranged. And of course, ang sobra at ang kulang are still bad for the body. Now, nutrients refer to the constituents of food. They can be either micro or macronutrients. Macronutrients can confer energy while macro cannot give you energy. Lastly, nutritional status assessment is performed to determine the health status of the patient in terms of anthropometrics, biochemical, chemical, and dietary studies done to the patient. That is the first step in management of malnutrition. As mentioned, there are actually 4 components needed to have a holistic nutritional status assessment. And these are your A, B, C, and D. Anthropometric, biochemical, clinical, and dietary. But for the purpose of our discussion, we're only going to focus on anthropometric and dietary assessments. Dahil ang biochemical and clinical assessment ay pag-uusapan in biochemistry itself and in other subjects, Pato, IM, and Pedia. Now, anthropometric assessment refers to the variation of your physical dimensions and gross composition of the body and how are they related with nutrition. And they are useful kasi kailangan mo siyang malaman to assess 1, growth failure in children, protein energy malnutrition, and body composition. Let's first focus on growth failure. in terms of growth failure in children, we have two major conditions, wasting and stunting. Wasting is gaano kapayat ang ating pasyente. This reflects acute malnutrition. So, ganito siya isipin. Di ba pa nagkasakit ka, ang expectation ay papayat ka kasi you have higher metabolism and you have poor oral intake. Now, in stunting, yan ay gaano ka kapanda or shortness. Now, this reflects chronic malnutrition. Ang ibig sabihin niyan, masyado nang matagal ka malnourished to the point na naapektuhan na ang iyong skeletal maturation and ang ating overall growth. Kaya ka merong chronic malnutrition sa taong merong stunting. Now, the best tool to identify wasting in children is your weight for height or weight for length status. Pero pag stunting naman, ito ay height, length for age naman. Pero kailan ba ginagamit ang ating length? Length is only being used up to 2 years of age, but height na pag 2 years of age onwards. Now, let's focus on PEM. Now, severe acute malnutrition of caloric and protein deprivation can manifest as either marasmus or kwashiorkor, which are both very prominent in children. The problem in marasmus is that sobrang konti ng calories na naproprovide sa patient natin in terms of protein, fat, and carbs, to the point that general muscle wasting sets in. But in kwashiorkor, ang problema ay mainly only protein deprivation. Sobrang konti ng protein mo, because of that, you will have an edematous state. Kasi remember, the albumin in the protein in the blood is the protein in the blood that confers oncotic pressure. Siya yung pressure na humahatak ng tubig from the interstitial component of the body going to the intravascular component. In kwashiorkor, you have low protein intake. Therefore, you have low albumin levels. Kaya tumatagas ang tubig sa iyong interstitial space. You become edematous in the process. You will have ascites kasi may tubig ka sa iyong baga. And you have fatty liver kasi you have low apolipoproteins, the proteins that transfer lipid molecules from the liver to other sides of the body. Dahil bawas din ang iyong apolipoproteins, nagsistay ang iyong lipid sa iyong liver. Therefore, you will have fatty liver disease. And of course, since you have poor nutrition in general, you have poor protein, you will have poor keratinization of the skin leading to a flaky plate appearance. Take note guys, this mnemonics, okay? Marasmus, muscle wasting, and in kwashiorkor, you are protein deficient meals. You take protein deficient meals. M, malnutrition, E, edema, A, anemia, L, liver that is fatty, and S, having skin lesions that are flaky, paint in appearance. And as mentioned guys, let's talk about body composition. BMI refers to the weight of a person divided by the height in meters squared. It is an indirect indicator of body fatness. It is very inexpensive and easy to use. And it is correlated with various metabolic problems such as hypertension and diabetes. Now, we also have other methods for body measurements, but are not always available. Thus, it is difficult to standardize them across observers, which can complicate research and even clinical assessment. Hence, mas ginagamit ang ating BMI for these purposes of determining body fatness. Now, take note of general trends across races, ages, and level of physical activity. Women tend to have more body fat than men, blacks have less body fat than do whites, Asians have more body fat than do whites, older people tend to have more body fat, and athletes have less body fat than do non-athletes. Take note that there are two BMI classifications, the WHO classification and Asian classification. We belong under the Asian classification. Please take note that in Asian classification, it is only up to obesity class 2. And if ang BMI mo ay above 25, ikaw ay obese already, meaning you are more prone to having different metabolic problems. of overnutrition. So take note of this categorization. On the other hand, abdominal obesity reflects visceral fat deposition. Kung gaano karami ang taba mo na naiimbak sa iyong tiyan. This is an important parameter because abdominal or visceral obesity is a strong predisposing factor for cardiovascular diseases. Now, to identify the two parameters used to describe abdominal obesity, we should know first how to retrieve the waist and hip circumference of a patient. Now, kinukuha ang ating waist circumference at the midpoint between the top of the iliac crest, okay, and the lower margin of the last palpable rib at the mid-axillary line. So, yan siya. This is the waist. While the hip circumference is the largest circumference at the level of the buttocks. Okay? So, we have here naman the two most common methods for measuring abdominal obesity. Between the two, we have your waist circumference and waist hip ratio. No, kanina, di ba, na common yung waist sa hip ratio mo, pwede mo siya makuha this ratio. Kaso, this is actually less favored kasi it takes time para makuha siya. But waist circumference is easier to obtain. You only need to measure the waist of the patient. Hence, it is more favored in more studies. Now, take note of these waist circumference values. The classic definition, guys, is pag men ka, you only have significant abdominal obesity if you have more than 102 centimeters. For females, kailangan more than 88 siya. But, in defining metabolic syndrome, we have different categorization. Iba siya depending sa ating race. Okay? And also take note the WHO waist ratio. For men, it's more than 0.90 para masabi meron kang obesity. Pag women naman, it's more than 0.85. Now, the major concept but you need to know here in dietary assessment are the dietary reference intakes. This is a general term for the set of reference values used to plan and assess the intakes of healthy people for a specific nutrient. Ang ibig sabihin niyan, may sariling set of DRI ang vitamin A, may sarili si vitamin C. Kumbaga, sineset niya kung gaano ba dapat karami yung nutrients sa daily diet ng isang healthy na patient para masustain ang kanyang normal functioning. Now, it has 4 standards and are specific to age group, physiologic state, and sex. Therefore, okay, take note guys that DRIs are designed to meet the needs of the healthy people only, not the needs of the sick population. Therefore, we follow a different set of reference values for those who are sick. That is why renal patients have different diet composition than those of cardiac and DM patients, and of course, those of normal patients. Now, DRIs have 4 reference standards: EAR, RDA, AI, and UL. EAR stands for Estimated Average Requirement, refers to the average daily nutrient intake estimated to meet the requirement of 50% of the healthy population. While RDA naman is the average daily nutrient intake level to meet the requirement of 97-98% of the healthy population. Now, sinasadya siya para magka-provide ng margin of safety for most individuals during nutrient acquisition. Now, look at this formula. To get the RDA, you must get first the EAR of the specific nutrient. Okay, kasi kailangan mo makuha ang kanyang value para makuha mo yung kanyang 2 standard deviation to get your RDA. Therefore, EAR is needed to establish the RDA for a specific nutrient. Now, adequate intake for a specific nutrient only exists when that nutrient has no EAR and RDA. May mga nutrients kasi na hindi nila ma-estimate ang kanilang EAR for proper nutrition. So, because of that, they only establish the AI on that available scientific information. Okay, example, Example, some nutrients, wala silang EAR saka or DA. Meron na silang AI lang talaga. Okay? Now, lastly, UL refers to the highest average daily nutrient intake level that is likely to pose no risk of adverse health effects. Okay, to almost all generations in a certain population. Example, the UL of vitamin A from retinol is 3,000 micrograms. If ang intake mo for a specific day is more than 3,000 micrograms, the potential risk for adverse effects from vitamin A will also increase. Now, how do we interpret these dietary intakes? Kapag ang intake mo ng isang nutrient ay below the EAR and RDA, they are considered inadequate. Kailangan kasi dapat nasa more than ka ng RDA intake mo of a specific nutrient in a day para ma-sure tayo na masusustain ang normal functioning ng around 97 to 98% of our healthy normal population. Confident ka na hindi ka magkakaroon ng undernutrition. So, if the value of the intake for a specific nutrient is at or above RDA, it is now considered adequate. Okay? Now, Doc, paano naman yung mga nutrients na walang EAR and RDA? As mentioned, you have your adequate intake value. So, para magkaroon tayo ng adequate intake of that specific nutrient, dapat the intake should be at or above the adequate intake value to be adequate. Now, lastly, to ensure na wala kang adverse effects, dapat the intake should always be less than the upper limit. Okay? But, dapat more than ka the RDA. This is the healthy zone dapat. This is the adequate zone. Okay? Pag more than ka ng ating UL dito, mapas ka dyan bali sa ating upper limit, the risk of adverse effect now increases. Now, energy requirement varies from person to person. Various formulas can be used to predict the estimated energy requirement, or EER, needed to maintain an energy balance. Okay? An energy balance is achieved if the calories consumed is equal to the energy expended. Basically, energy balance yung pinagandang term lang for maintenance of body weight. Now, for simple approximations, the level of activity allows us to approximate the energy requirement to maintain body weight or energy balance, as you can see in the table. Very active adults need to consume more calories to maintain their body weight. Pero gaano ba karami ang energy content for a specific food? Now, to calculate them directly, we need to perform a bomb calorimeter. Inside this machine, the food is burned and the heat released by the total combustion of the food in the calorimeter is then your total energy content. Now, for carbs and proteins, lagi siyang 4 kilocalories per gram. 9 kilocalories per gram ang ating fat. And yes, guys, for alcohol, it's 7 kilocalories per gram. Kaya guys, hinay-hinay lang sa ating alak. And note, guys, that 1 kcal is equals to 4.2 kilojoules. Guys, this was asked before, so take note of this concept. 1 kilocalories equals to 4.2 kilojoules. No, so for example, guys, what is the total amount of kilocalories in a diet consisting of 1 gram of carbohydrates, 3 grams of fat, 4 grams of protein, and 2 grams of alcohol? Know their values and combine them with the total amount of weight per macromolecule, leading to 61 kilocalories in total. Now, your total energy expenditure refers to the number of kilocalories expended by the above-mentioned processes in a 24-hour period. The thermic effect, physical activity, and RMR. Thermic effect refers to the diet-induced thermogenesis, which occurs during digestion and food absorption. So, kahit nag-digest ka, you still need to have energy expended para magawa sila. Check. RMR refers to the energy expended by a person in a resting post-absorptive state. While physical activity among them has the greatest variation kasi It will depend on your physical activity. If you have sedentary or even if ikaw ay mas madalas mag-exercise. But among them, the most important in terms of distribution is always your resting membrane rate or your BMR. Now, kailangan din guys, alam niyo yung ating mga AMDR ranges. Your acceptable macronutrient distribution ranges. They're defined as range of intakes for a particular macronutrient that is associated with reduced risk of having chronic disease while providing adequate amounts of essential nutrients. Now, for carbs dapat, diet should consist of around 45 to 65%. Protein should be 10 to 35%, while fat should be 20 to 35%. And dapat, guys, meron kang dapat na limits sa mga pagkain ng mga fat na trans fat, saturated, pangapufa, sa mga simple sugars. You have to modulate them. And you have to memorize these values kasi they can be asked in the PLE. Okay? Now, dietary fiber naman refers to a non-digestible, non-starch carbohydrates and lignin present intact in plants. Now, sa isang araw, dapat ang lalaki magkaroon ng 38 na grams per day, while women should have 25 grams per day. Kasi they're very important. They soften the tool and reduce the risk for constipation and having hemorrhoids. They increase bowel motility, and of course, they also decrease the plasma cholesterol via increasing your bile acid excretion in the stool. So, kailangan sila para magkaroon ka rin ng sensation of fullness. Very effective siya in patient having nag-diet mga pasyente. And they can blunt the glycemic response para konti lang ating intake of further carbohydrates. Now, glycemic index naman ranks the carbohydrate-rich foods on a scale of 0 to 100 based on the glycemic response. Okay? So, they're actually based on the amount of carbohydrate eaten in the form of a white bread or glucose. Pag ang iyong GI ay less than 55, evidence shows that you may improve the glycemic control in diabetic individuals. And these foods have a potential to create satiety over a longer period of time. So, low GI is preferred among diabetic patients para less sugar sila. While a high GI diet, kapag more than 70 sila or 70, pangit sila kasi it means mataas ang kanilang glycemic response in the body. So, you prefer diet having low glycemic index. Now, the quality of protein is based on the amount of amino acids and type of amino acids present that can be measured via the following parameters. PDCAAS, termed as protein, digestibility, corrected amino acid score, BV or biological value, NPU or net protein utilization, PER or protein efficiency ratio. Now, PDCAAS refers to the FDA standard used to evaluate protein quality based on the profile of your essential amino acids. Pag 0 ka, lowest ka, 1 being the highest. So, among animal sources, pinamataas sa value ang ating egg saka milk. They almost have a value of 1. While in plant sources, in general, lower in quality, but soybean can have a value of 1. BV and NPU, halos pareho sila. Kasi both numerators are nitrogen used in tissue formation. Pero in BV, the denominator is actually absorbed from food nitrogen. But in NPU, the amount of nitrogen na ingest mo bali. Okay? And same with PTCAAS, the range is 0 to 1, with 1 being the highest. But in PER, it determines the efficiency of a protein through the measurement of animal growth among rats, for example. Now, the value is compared to a standard of 2.7. You will have an excellent source of protein if the PER is at least a value of 2.7. And poor lang kapag less than 2.7 ka. Now, breastfeeding is also important in nutrition, guys. Don't forget it, guys. Very important. And let's have a review of those hormones involved. Estrogen, ductal development. Progesterone is for epithelium differentiation, and lobular development. Prolactin, lactogenesis, and oxytocin for the expulsion of milk into the lactiferous sinuses of your areola. And take note that you have two types of milk produced during breastfeeding, the colostrum and the mature milk. Colostrum is produced at the 12 to 6 week of pregnancy. Ganun siya kaaga. And relatively, it is rich in IgA para defense sa bata, more minerals and amino acids, and less sugar and fat. While in the mature milk, usually found during puerperium, less minerals na siya, pero, and more sugar and fat na siya. So, mas packet yung kanyang quality. Hence, eventually, kapag kailangan mo na mag-transition sa foods afterwards. But both types of milk has low amounts of vitamin D and virtually absent vitamin K. Kaya, you must provide vitamin K to neonates after delivery. And that's all for your nutrition. Okay. Now we head to your vitamins and minerals. Starting first with your vitamins. Nutrients are necessary to sustain normal body functions. They can be either macronutrients or micronutrients, depending on the amount needed by the body. In general, macronutrients can provide calories. These are proteins, carbs, lipids, and ethanol. While micronutrients naman are vitamins and minerals. Now, vitamins are organic substances, and they can be destroyed with heat and chemical reagents. But minerals are inorganic. They are actually very resistant to heat, sunlight, and even chemical agents. So you have to know them. And also, you have to know this concept, your deficiency and toxicity. Toxicity is the abnormal accumulation of a certain nutrient in the body, while deficiency is the lack of a certain nutrient in the body. Now, let's first talk about your vitamins. Vitamins are classified into two major categories, fat-soluble and water-soluble. So, we have your vitamin A, D, vitamin B, and your vitamin C. A, D is soluble in lipid medium. They are absorbed by your chylomicrons and can be stored in the liver and adipose tissue. They are not readily excreted. Hence, they have a risk for toxicity kasi they stay mostly in the body. In contrast, your vitamin B complex, sorry for that, and vitamin C mainly stay in the aqueous medium. Okay, they are directly absorbed via circulation and they're readily excreted in the urine. It means araw-araw mo sila iniihi. Therefore, they are low risk for toxicity. Now, kapag addict ang isang tao sa'yo, usually mas clingy siya. So, mas toxic siya in the process. So, ingat guys sa toxic clingy. Okay? Now, we have some vitamins synthesized by the body itself. Vitamin D can be found from precursor steroids, mainly from 7-dehydrocholesterol. Vitamin K, biotin, and pantothenic acid can be made by the intestinal microflora, and niacin can be derived from tryptophan, an essential amino acid. But this requires vitamin B2 and B6, so it is not preferred. Mas maganda na makuha mo siya from the diet. Now, addict vitamins are mainly stored in the liver. Okay, to be specific, vitamin A is stored at the stellate cells of Ito and can be stored for up to 6 months according to Robbins and Cotran. In general, water-soluble vitamins are found in the aqueous compartments of the body, except for vitamins 9 and 12. They are both stored in the liver. And according to Harrison's, the storage period of folic acid is up to 3 to 4 months, while cobalamin can be stored for up to 3 to 4 years. Let's first talk about your fat-soluble vitamins, your vitamin A. Vitamin A refers to all compounds chemically related to retinol. Those are your retinoids. You have your retinal, retinoic acid, retinol, and retinyl ester. Among them, retinol is the form absorbed by intestinal cells. And take note guys that your metarhodopsin 2 is important kasi it's the one that activates your transducin, causing retinal hyperpolarization. Important siya for vision. Now, carotenoids naman are provitamins of vitamin A, found in plants. They can be metabolized to vitamin A in the process. Now, beta-carotene is most prevalent in the food supply that has provitamin A activity. Now, beta-carotene will then become retinol eventually para siya ay ma-absorb ng ating katawan. Kasi take note, retinol is the form of vitamin A that can be absorbed by your intestines. Now, during absorption, as mentioned, your B-carotene should become retinol and your retinol ester should become retinol. Kasi retinol is the form being absorbed by your intestinal cells. Eventually, after absorption, they are re-esterified as retinal esters in the intestine and are transported in chylomicrons via lacteals and lymphatics from the intestine going to the liver eventually. And at the liver, they will be uptaken by your apolipoprotein E receptor, and these can be stored into the eto cells of your liver for further use. Now, if you want to transfer vitamin A from the liver to target organs, they must be carried by your RBP or transthyretin. Again, guys, the eto cells is a site of vitamin A storage. Now, vitamin A is important for vision maintenance, normal production, and maintenance of skin and mucosa. It's responsible for prevention of having metaplastic differentiation. And they have an antioxidant properties, mainly your beta-carotene. Kasi the beta-carotene can replenish your vitamin E in the body. When it is deficient, it can cause xerophthalmia. It's the collective term for all ocular manifestations of vitamin A deficiency. The earliest sign is loss of sensitivity to green light, while the earliest symptom is nyctalopia or night blindness. You can also have cirrhosis, dryness of the conjunctiva, bitot spots, having white patches, at the sclera, and keratomalacia or the softening of the cornea. Eventually, they can lead to corneal ulceration, which is very painful because of the pain fibers located at the cornea. Besides ocular manifestations, you can also have toad skin or phenoderma, which forms as metaplasia of the epithelium leading to follicular hyperkeratosis, seen in this image. And of course, as mentioned, kailangan mo siya, ang vitamin A, to prevent squamous metaplasia. For example, ang ating respiratory tract can have metaplasia, loss of cilia, loss of microvilli, and mucus production can lead to bacterial stasis, leading to an increased risk of infection, mainly measles virus infection. Now, vitamin A toxicity can also occur, usually among Arctic explorers eating polar bear liver. Now, if acute ang kanyang form ng kanyang toxicity, they can present as pseudotumor cerebri, having headache, vomiting, stupor. While in chronic problems of vitamin A toxicity, you can have hip fractures, and for pregnant patients, they can have teratogenicity. Vitamin D refers to a group of sterols having a hormone-like function. Okay, they can be derived from two sets, ergocalciferol, vitamin D2, or cholecalciferol, vitamin D3. Ergocalciferol is the form of vitamin D obtained from fungal organisms, mushrooms, and ergots, while D3 is the one derived from 7-dehydrocholesterol via UVB radiation. Now, dietary vitamin D can be transferred from the intestine to the circulation via your chylomicrons and transported eventually to the liver via your vitamin D binding proteins. At the liver, vitamin D becomes 25-hydroxycholecalciferol via 25-hydroxylase. And it is the most abundant circulatory form of vitamin D, the 25-hydroxycholecalciferol. Now, this form of vitamin can become your 125-dihydroxycholecalciferol, also known as calcitriol, via the alpha-1 hydroxylase found in the kidneys. And this enzyme serves as the rate-limiting step of vitamin D metabolism. Take note that the most active form of vitamin D is your 125-cholecalciferol, also known as calcitriol. Now, in the case of high levels of calcium in the blood, your 25-hydroxycholecalciferol can become 24,25-cholecalciferol, also known as your calcitroic acid. And kidneys produce this inactive metabolite, calcitroic acid, para sila ay ma-excrete in the urine in the process. It only occurs in high levels of calcium in the blood para hindi magkaroon ng excess na vitamin D na active. For your review guys, the most active form is your calcitriol. The most inactive is your calcitroic acid. But the most abundant is your 25-hydroxycholecalciferol. Vitamin D is mainly for calcium and phosphorus homeostasis and has immunomodulatory effects, and is responsible for bone mineralization. Take note, high levels of active vitamin D can increase the calcium and phosphorus absorption in the GI tract. If you have vitamin D deficiency, can lead to rickets in children and osteomalacia in adults. But in large amounts, take note that it can cause hypercalcemia. In hypercalcemia, of course, calcium is an important molecule for contraction. It can constrict your vessels, leading to hypertension. And moreover, high levels of calcium can lead to deposition of calcium in soft tissues, known as metastatic calcification. Vitamin E contains tocopherols and tocotrienols and represent the most powerful naturally occurring antioxidant. We have here the most potent form, alpha tocopherol. And take note guys, the different micronutrients with antioxidant effects. Your A's, zinc, selenium, vitamin A, vitamin C, vitamin E, zinc, and selenium. For vitamin A, as mentioned, it's mostly your beta-carotene because they can replenish your vitamin E in the body. Vitamin E can present as having demyelination of your posterior columns and spinocerebellar tract. Take note of that guys it involves the posterior columns of the patient. And dahil wala kang vitamin E, you have high risk for having radical formation leading to lipid peroxidation of your membranes, mostly of your RBCs. Because of that, you can have acanthocytosis of your RBCs. And dahil pangit ang kanyang membrane, pag dumaan siya sa capillaries, they can lead to hemolytic anemia. Now, vitamin K naman, the coagulation vitamin, it is required for the post-translational gamma carboxylation of glutamic acid. Necessary step for calcium binding to the following proteins. For your very famous coagulation factors, we have your factors 1972, 10 to guys, not 1 it's 10, 9, 7, and 2, and protein C and S. Of course, if you have poor vitamin K in the body, can lead to bleeding problems, while excess amounts can lead to kernicterus or CNS damage. But why are infants prone to having vitamin K deficiency? Remember, vitamin K is a fat-soluble vitamin. Thus, patients with low fat stores, such as infants, which are mostly water, are more susceptible to vitamin K deficiency. Recall that vitamin K can be synthesized by the intestinal microbiota. So, absence in neonates leads to further problems. And of course, as mentioned previously, vitamin K is virtually absent in breast milk. Therefore, neonates have high risk for vitamin K deficiency. Hence, they must be administered after childbirth. Now we head to your vitamin C, also known as your anti-scorbutic factor. Now, humans and other primates cannot make their own vitamin C due to the absence of this enzyme, your gulonolactone oxidase, found in the uronic acid pathway. Vitamin C is very important. It is a good reducing agent, a strong antioxidant, is important in collagen synthesis, conversion of dopamine to norepinephrine, and in the conversion of your ferric iron to ferrous iron, since ferrous iron is the one being absorbed in the duodenum. Again guys, ferric Fe3+, naging Fe2+ siya. There is reduction. And that is being made by your vitamin C because it is a good reducing agent. So in vitamin C deficiency, guys, you can have scurvy and a weakened immune response. In scurvy, you have gum bleeding, bleeding diathesis, poor wound healing, and you have a corkscrew hair in the process. Take note, guys, that in vitamin C problems, pag sobrang dami naman niya, it can lead naman to calcium oxalate nephrolithiasis. And as mentioned, guys, vitamin C can increase the absorption of iron in the body. Therefore, large amounts of vitamin C can lead to risk for iron toxicity in the process. And take note that vitamin C mega dose can lead to GI effects, mainly diarrhea. So if you take large amounts of vitamin C, pwede ka magka-diarrhea. Doc, bakit may mega dose na vitamin C? Kasi some proponents think that the absence of vitamin C in humans causes the multitude of disease in man. So kailangan mo daw siyang i-supplement with vitamin C. But of course, hindi naman siya talaga wholly true in the process. Now we head to your water-soluble vitamins. The rest of them, your vitamin B complexes. Now first, take note of their active forms and common names. B1 thiamine, your thiamine pyrophosphate. B2 riboflavin, FAD and FMN. B3 niacin nicotinic acid. Active form, NAD and NADPH. B5 your pantothenic acid, your coenzyme A. B6 your pyridoxine, your pyridoxal phosphate. And B7 or H or biotin, your enzyme-bound biotin. Take note of their important functions. B1 is for decarboxylation, B2 and B3 for redox reactions, B5 for fatty acid synthase and a component of their coenzyme A, B6 is mainly for amino acid metabolism, and a coenzyme siya for your glycogenolysis, specifically for your glycogen phosphorylase. And your B7 or H for carboxylation transfers. Again, redox, B2 and B3. Tapos B1 dapat and B6 are also important. B1 if you have large intakes of carbohydrate and B6 naman for large amounts of protein intake. You have to have increased vitamins for those kinds of intake in the body. Now, let's talk about your vitamin B deficiencies. As mentioned, guys, water-soluble vitamins are more prone to deficiencies kaya sobrang dami nila dito. Okay? B1 has two forms. Okay? Your wet beriberi and dry beriberi when B1 is deficient. Now, ang ating wet beriberi, it can lead to your high output heart failure. While ang dry naman can present as your Wernicke-Korsakoff syndrome. Pag Wernicke ka pa lang, it's still reversible. You have confusion, ophthalmoplegia, and ataxia. Pero if you have dementia na, tsaka confabulation, irreversible na ang ating dry beriberi. You're now having your Korsakoff syndrome. Okay? In B2 deficiency, think of 2 Cs. Okay, low Cs and corneal vascularization. While in vitamin B3, think of your pellagra. 3 Ds, dermatitis, having your kasal necklace seen in the image here, having a dementia, and having diarrhea. Those are components of your pellagra. Now, in vitamin 5 deficiency, B5 deficiency, you can have your Goplan's burning feet syndrome. And take note of your paantothenic. Paantothenic, paa ang problema sa ating vitamin B5 deficiency. Now, your vitamin B6 is expected to have problems concerning amino acids. You can have neuroproblems, manifesting as seizures due to imbalance in the neurotransmitters, which are mostly amino acids. You can have anemia. But take note, guys, that both vitamins B6 and B12 can cause pellagra-like syndrome because both are needed to convert 60 milligrams of tryptophan into 1 milligram of niacin. That is the ratio. But between the two, vitamin B6 is more important in this pathway. Thus, it is more likely to produce pellagra-like symptoms than your vitamin B2 deficiency. Lastly, we have your vitamin B7 or H or biotin, and it can cause dermatitis, enteritis, and alopecia if you take large amounts of antibiotics and ingestion of raw white eggs because of the amount of avidin. And take note that avidin in egg whites and in antibiotics can bind avidly to biotin in the intestinal lumen, causing impairment in biotin absorption in the digestive tract. Now, dahil nga lagi mong iniisip vitamin B and C, medyo rare ang kanilang toxicity. And as seen here guys, you only have B3 and B6 having the more prominent toxicities. B3 can cause podagra because of high risk of hyperuricemia causing gout in the first MTP joint. Take note guys ha, ang deficiency in B3 is pellagra. So magatunog sila dapat. And of course, it can cause hepatotoxicity and facial flushing. B6 naman can cause sensory neuropathy. Now, let's talk about the last two, B9 and B12. Now, medyo kakaiba sila. They are both stored in the liver, right? Medyo kakaiba from usual water-soluble vitamins. B9 is absorbed mainly in the jejunum, while B12 in the ileum. Active verb ng B9 ay THF, while ileum ay methylcobalamin and deoxyadenosylcobalamin. B9 is mainly for transferring 1 carbon units, seen in methionine synthesis, serine, nucleotides, and even your thymidine monophosphate. Pero kakaiba ang ating vitamin B12. It is only seen in 2 reactions in the body. 1, methionine synthesis from homocysteine, and 2, succinyl-CoA synthesis coming from methylmalonyl-CoA. Doon lang po siya nakikita. Now, in deficient amounts, both B9 and B12 can cause reversible macrocytic megaloblastic anemia. And sa iyong PBS, pwede ka makita ng hypersegmented na neutrophils. But there are no neurosymptoms in B9, but neurosymptoms are present in B12, having irreversible subacute combined degeneration of her dorsal columns. Now, parang may kapareho siya, right? It's your vitamin E deficiency. Both can have demyelination of the posterior columns, pero in vitamin E, the pathogenesis of anemia is hemolytic in nature due to acanthocytes bring up by your lipid peroxidation due to the lack of vitamin E in the body. But in B12, ang problema dyan ay the production of your RBCs. Mahina siya kasi you have B12 deficiency. Now, comparing yung B9 and B12, both have increased homocysteine ha. Take note of that. And they can be clue in diagnosis. And recall that homocysteine amounts can lead to high risk for cardiac events. Both also have folic acid deficiency. Nagkakaiba lang sila in terms of methylmalonic acid, wherein it is only elevated in B12 but normal in your B9 deficiency. Now, the B12 absorption and transport to the body is actually kind of unique. Okay? Now, B12 is first found in the food, of course. Now, the body has haptocorine or transcobalamin 1. And this is mainly produced by the salivary glands. Ang nangyari dyan, guys, once the B12 is found in the stomach, it is then released from its binding protein from the food. When that happens, ang nangyayari, the haptocorine then binds with the B12, forming a haptocorine B12 complex. It happens at the level of the stomach. Now eventually, at the level of the duodenum, naghihiwalay ang ating B12 and haptocorine. Naghihiwalay sila, okay? This time, free ulit si B12 natin. Ang sasama sa kanya, sa duodenum, up to the rest of the GI tract, is now the intrinsic factor, produced by the parietal cells of the stomach. It binds at the level of the duodenum, okay, to the B12. Eventually, once this complex of intrinsic factor and cobalamin reaches the terminal ileum, meron diyang mga covalent receptors, allowing the uptake of B12 intrinsic factor complex at the terminal ileum. Eventually, B12 will then be absorbed by the body. And para ma-transfer si B12 sa ating katawan, in the circulation, kailangan mo ng transcobalamin 2 in the process. So for the sequence of events, guys, think of H. Haptocorine, intrinsic factor, terminal ileum, and cobilin. Okay, that is a good mnemonic for your vitamin B12 absorption and transport. And now we head to your minerals. Now, minerals, guys, are classified mainly based on their daily requirements. Okay? Macro minerals, more than 100 milligrams per day. Micro minerals or trace elements, less than 100 milligrams per day, while ultra trace elements are less than 1 milligrams per day. But Doc, how do you memorize such information? Ito lang yan. So in this case, I will only memorize the ultra trace elements. IMS, iodine, molybdenum, and selenium. Then the more familiar ones, except for iron and zinc, are found here. Doing that, you can now memorize the table in 5 seconds. So, ganyan siya isipin, guys. Okay? So, yung mga very typical ones or macro minerals, okay? Tapos yung IMS mo, ultra trace lang. The rest are microminerals plus your iron and zinc. So, that's how you memorize tables. Find shortcuts, memorize a small amount muna, yung mga konti lang, kasi the rest can be saved pa for other pieces of information. Now, before understanding the steps in iron metabolism, let's first orient ourselves in the specific functions of the two major forms of iron, ferrous and ferric iron. Ferrous is mainly for oxygen binding and the one form absorbed by enterocytes. Moreover, guys, it is also important for the hydroxylation step of your collagen synthesis. Please write them down, okay? While ferric is mainly for transport and for storage. Now, ang nangyari dyan, guys, vitamin C must first convert your ferric state into the ferrous state para siya ma-absorb ng ating DMT1, the transportation of your Fe2 plus into the enterocyte. Now, what is the fate of iron in the enterocytes? One, they can be stored as ferritin when combined with apoferritin, or they can travel across the basolateral membranes and be absorbed into the circulation. But before that, para makasama siya sa ating transferrin, the Fe2 plus must become first Fe3 plus, diba? Fe3 plus kasi yung kailangan para maka-hitchhike ang ating iron sa ating transferrin. That occurs via your hephaestane. Hephaestane is a molecule containing copper. So, that copper-containing protein converts Fe2 plus to Fe3 plus para siya makakabit kay transferrin para siya ay makagalaw sa ating circulation. Therefore, copper deficiency can also lead to iron deficiency in the body. Kasi kailangan mo ng hephaestane para makatravel ang iron sa ating circulation. Now, some forms of iron may be derived from the body itself. Okay? So, for example, the heme coming from your hemoglobin. So, nangyari dyan, guys, hemoglobin becomes heme and globin. Globin go back to the amino acid pool. While heme naman becomes biliverdin via your heme oxygenase. And becoming biliverdin also releases iron to the blood. Now, ang iyong biliverdin naman will become bilirubin via your biliverdin reductase in the process. Now, iron metabolism is mainly controlled by your hepcidin. It is the chief regulator of systemic iron homeostasis. So, ano ba ginagawa niya? Increases in hepcidin actually decreases iron in the blood. Bakit? Kasi one, it binds to ferroportin. Ferroportin, ang ginagawa sa kanya, dinidegrade siya ng ating hepcidin para ma-decrease ang export of iron sa ating circulation. So, binablock ng hepcidin ang release ng iron from the macrophages and from the intestine, causing low amounts of iron in the blood. Okay. But, Yun yung nangyari sa kanya. And take note guys that hepcidin is actually upregulated when there are high amounts of iron in the blood and in cases of inflammation. Dok, bakit? Bakit kailangan tumaas ang hepcidin during inflammation? Because ang inisip ng katawan mo, if you have inflammation, baka meron kang infection. Baka meron kang bacteria. And bacteria loves iron. Kasi bacterial growth actually rises exponentially in the presence of iron. So, ang katawan mo, gusto mong itago ang iron sa ating circulation. You want to store it in the intestine or in the macrophages. Kaya tumataas ang ating hepcidin in inflammation. Now, on the other hand naman, hypoxia down-regulates hepcidin para tumaas ang level ng iron in the blood circulation para gumawa ka ng maraming hemoglobin in the process. Okay? Now, let's head to copper. Copper is a very prominent cofactor in various enzymes. One, as mentioned, Hephaestin, the one that can oxidize iron from ferrous to ferric form sa ating intestine para siya ay makakabit sa ating transferrin in the blood. That's one. Next, lysyl oxidase naman para sa cross-linking step ng ating collagen fibers. And also, in your superoxide dismutase, kailangan siya in zinc para gumana to. Now, copper metabolism can have two problems. One is Menkes disease, having overall decrease in copper in the body due to an X-linked recessive mutation of your ATP7A. Dito naman guys, copper is not mobilized into the intestine. It's not mobilized from the intestine to the body. Therefore, konti ang copper mo sa other parts of the body mo. You can have neuro problems, you can have a kinky or steely hair problem. In contrast, corkscrew hair ang meron sa ating vitamin C deficiency naman. So, kakaiba sila. Now, in Wilson disease naman, we have the autosomal recessive ATP7B mutation causing to increase copper in the body. And copper is then stored in different organs. Okay, meron sa liver, meron sa CNS. So you can have liver dysfunction, you can also have neuro problems in the process. And of course, in the eyes, they can be stored in the descendant layer of the cornea, presenting as Rickettsia Fleischer rings. Zinc is also an important cofactor in different enzymes. Of course, one of them is your cytoplasmic SOD, copper and zinc. And it can form your zinc can form your different structural functions. You can form zinc fingers, can maintain the insulin hormone structure. And also for fetal growth and development. Kailangan din siya. And it is also required for normal spermatogenesis. Now, take note guys of the different sperm requirements. Zinc for normal spermatogenesis, and fructose is the energy for sperm motility. Now, you can also have this problem in zinc, an autosomal recessive problem known as your acrodermatitis enteropathica. In this case, you have a problem in the genes causing poor zinc absorption, leading to poor zinc in the body. It can manifest as vesicular rashes and diarrhea. Kaya siya acrodermatitis. Acrodermatitis, rashes of extremities, enteropathica, diarrhea in the process. Now, for the other minerals, guys, manganese is an important cofactor seen also in SOD, but this time, the one found in the mitochondria. Okay? Molybdenum, a cofactor for different oxidized enzymes. Cobalt for cobalamin. Chromium is a potentiator for insulin action. In contrast to zinc, it can cause, ang zinc mo naman kasi insulin structure stabilization. Pero ang chromium mo, ang ginagawa niya ay potentiation of action. Fluoride for bone and teeth, and selenium is strong antioxidant as mentioned. In deficient states, it can cause Kishan cardiomyopathy, while in excess naman, can cause your Cushing-Beck disease. And that is all for your vitamins and minerals. Now, we head to your complex molecules. Complex molecules are the following: glycoproteins or mucoproteins, glycosaminoglycans or mucopolysaccharides, glycerophospholipids or phosphoglycerides, phingolophospholipids, glycolipids, and your eicosanoids. First are your glycoproteins. Guys, kung ano ang kanyang apelido, yun ang kanyang mas maraming content. So, proteins are more prominent here. Now, these are mainly found in surfaces of your structures kasi they can cause cell surface recognition and antigenicity. Sila yung makita sa mga surface ng ating mga cells in the process. And they can be involved in cell trafficking. While glycosaminoglycans are mainly carbohydrates in structure. They are unbranched polysaccharides consisting of repeating disaccharide units or alternating acidic sugar and amino sugar. Now, GAGs are normally linked to a protein core, as you can see here, except for hyaluronic acid. So, you only have your very, very big hyaluronic acid. And take note that these are not linked to a protein core. Pero kapag ang GAG ay nakalink sa isang protein core, as you can see here, ang tawag sa kanya as a whole ay proteoglycan. Okay? So those are the terminologies. Protein core, the one at the center, plus the GAGs, form your proteoglycan. While your hyaluronic acid do not link to a protein core. Therefore, they do not form proteoglycans. So what are the sugar units involved? Guys, you have to memorize this. They're now very testable now in the board exams. So I leave it to you for now, but take note guys yung kanilang location ng mga GAGs. Most GAGs are found in the synovial fluid. Chondroitin sulfate in the cartilage, keratin sulfate in the cornea, heparin in the mast cells, heparan sulfate in the kidneys, and dermatan sulfate in the skin. But among all of them, chondroitin sulfate is the most abundant GAG in the body, not hyaluronic acid. Okay? Take note of that. Next, we have your glycerophospholipids. Okay? So, we have here the following nomenclature for them. So, it could be a glycerol having two fatty acids known as a diacylglycerol, and they're attached to an alcohol. Okay, so iba-iba yan guys. And they can have the following. Kapag ang nakadikit ay hydrogen atom, ang tawag ay phosphatidic acid. Pag choline, phosphatidylcholine. Pag etanolamine naman, phosphatidylethanolamine. Pag inositol, phosphatidylinositol. Pero kapag ang dumikit sa kanya ay kapwa DAG, ang tawag ay cardiolipin. Now, they are actually distributed well along the two leaflets of your cell membrane. Pag outer leaflet ka, you have choline and sphingomyelin. Pero pag inside ka or inner leaflet, you have the following: ethanolamine, serine, and inositol. Among all of them, choline is the most abundant, followed by ethanolamine. Now, serine naman, as mentioned, it's mainly inner leaflet. Pero during apoptosis, it goes from the inner leaflet to the outer leaflet to signal apoptosis in the process. Ang sinasabi niya ay, guys, I'm dying, so you may kill me already. Okay? Inositol naman is a reservoir of arachidonic acid, and they can also serve as sources of your ITP and DAG, which are members of your messenger system for signal transduction. Next, we have your sphingophospholipids. And we have here your sphingomyelin. Okay, it's the most important among them and the main constituent of your myelin sheath. Next are your glycolipids. Glycolipids, lipids ang pinakamarami sa kanila. They're actually essential components of your cell asymmetry of your membrane. And they are seen in cell adhesion, recognition, and your neural tissues. So, in excess amounts in problems of the body, they can cause your sphingolipidosis, Tay-Sachs disease, Niemann-Pick disease, and your Gaucher disease. And lastly, we have your eicosanoids. So, they are the compounds derived from the 20-carbon fatty acid, arachidonic acid. Now, to produce them, we have two major pathways. First is your cyclooxygenase pathway, and the other is your 5-lipoxygenase pathway. Under this pathway, we have your prostacyclin, a natural platelet aggregator and vasodilator. Ang kanyang kalaban ay thromboxane A2, a vasoconstrictor and platelet aggregator naman siya. We also have here your prostaglandins. PGE2 is the one for fever, while dito naman is for chemotaxis. Ang sinasabi niya, guys, dito kayo pumunta sa site of inflammation. It calls the monocytes and the different neutrophils. Dito kayo pumunta, it's a chemotactic factor. Now, for the lipoxygenase pathway, it contains your leukotrienes, C4, D4, and E4. They can cause bronchospasm and increase vascular permeability. They are the ones predominant in asthma. So you must counteract them with some drugs such as leukotriene receptor antagonists. But they have an odd man out. Si B4, along with 5-HT, are strong chemotactic agents. Same with TG, D2. Okay? Lastly, we have your lipoxins. The rest of them are pro-inflammatory, but lipoxins are anti-inflammatory nature. So they are the only eicosanoids that are anti-inflammatory in nature. That's all for complex molecules. Now we head to some basic concepts of enzymology. Enzymes are protein catalysts. They increase the velocity of the reaction, but do not affect the chemical equilibrium. Now, ang ginagawa niya ay, it lowers the activation energy of a chemical reaction. Think of activation energy as the Great Wall of China. At you must overcome so that a chemical reaction would move forward. Parang ganito, binaba niya to from here to here. With that, mas madali siyang move forward kasi you only need low amount of energy para matuloy ang ating reaction process. If that wall is lowered by enzymes, the chemical reaction would be faster since less effort is needed to climb that great wall. Pero, it does not affect the chemical equilibrium. It will only affect the velocity or rate of the reaction. Mostly, enzymes are proteins, but for some cases, we have ribozymes, which are RNAs having catalytic activity. Now, enzymes can be classified based on their classes. Class 1, we have your oxidoreductases, involved in redox reactions, transferases, which moves chemical groups from one substrate to another, hydrolases, using water to cleave substrate bonding, lyases, which catalyzes cleavages of bonding without the use of water, isomerases, which rearranges substrate molecules to form a different isomer, and ligases, which catalyzes the formation of bonds among different atoms. We also have your phosphatases, which remove phosphate groups, and phosphorylases or kinases, which adds a phosphate group to the substrates. Now, enzymes have the following properties. 1, they have an active site kung saan pumapatong ang ating substrate. They're highly efficient, highly specific, and they can be compartmentalized. Meaning some enzymes are only found in the cytosol, some in the mitochondria, some naman at the level of the lysosomes. So that's good para hindi maghalo-halo yung ating mga metabolic processes. They can be regulated or inhibited, okay, via modification of the different rate-limiting enzymes. And some enzymes require non-proteins for their activity. Now, simple enzymes consist only of protein, and they function alone. But complex enzymes are those that contains a protein plus a non-protein component. Now, ganito yan guys. Ang tawag sa complex enzyme na walang non-protein component ay apoenzyme. It is the only protein of the enzyme. Pero pag sinamahan mo siya ng non-protein component, nagiging na siyang complex enzyme in the process. Now, apoenzyme, as mentioned, is the enzyme without its non-protein component. It is inactive. Okay? Now, it becomes active kapag nasama na yung kanyang non-protein component. So again, ibig sabihin yan guys, the holoenzyme is the protein component or apoenzyme plus the non-protein component. Now, the non-protein component can be either a cofactor or coenzyme. The cofactor is always a metal ion or the minerals, while coenzymes represent your small organic molecules, usually derived from your vitamins. Now, magbabago pa yan. Pag ang vitamin mo or coenzyme is transiently na naka-associate sa ating enzyme, ang tawag sa kanya ay co-substrate. Pero kapag ang iyong vitamin or coenzyme ay permanently naka-associate sa enzyme, ang tawag sa kanya ay prosthetic group. Effectors are not required for the functioning of your enzymes, but they can affect the rate of the reaction. So, if you have a positive effector, the rate will increase. If you have a negative effector, the rate of the reaction will then decrease. Now, let's discuss basic concepts in enzyme kinetics. So, as you can see here, guys, the horizontal area is the concentration of the substrates, while the vertical naman is the velocity of the reaction. At point A, as you can see, guys, as you increase the substrate, the velocity of the reaction also increases. That is known as your first order kinetics, wherein the rate of the reaction is dependent to the concentration of the substrate. But at point C, guys, even if you increase the amount of substrate, the velocity of the reaction remains the same, reaching a Vmax, okay, or maximum velocity, because the enzymes are already saturated. Ang tawag dyan ay zeroth order kinetics, wherein the rate of the reaction is now independent to the concentration of the substrate. First part, first order. Last part, zeroth order na siya. And your Michaelis Menten kinetics is the one able to explain the hyperbolic curve attained between the velocity of an enzyme catalyst reaction and the concentration of your substrate. Now, for some terminologies, guys, the Vmax, as mentioned, is the maximum velocity of a reaction. Okay? It is actually directly proportional to the amount of enzymes present. Enzymes, Vmax. Michaelis constant naman is inversely proportional to the affinity of the enzyme for its substrate. Therefore, a high Michaelis constant or Km, you have therefore a lower affinity between the enzyme and the substrate. Now, of course, factors may affect the rate of reaction. 1. Concentration substrate. If konti lang sila, mabagal yung ating rate of reaction. Second, temperature. Now, depende yan. Sa early parts of temperature increase, okay pa ang ating rate increase. Pero, pag dumating ka ng around 41 degrees Celsius, magkakaroon ka na ng slowing down. Kasi, that is the onset of protein denaturation in the body. Kaya ang tao may lagdag na sobrang taas, dapat pinabigyan ng paracetamol or tepid sponge bath kasi you don't want to have a temperature beyond 41 degrees Celsius kasi masisira ang iyong different proteins in the body, causing permanent damage in the long run. Now, pH is also important kasi some enzymes act better at basic, medium, while some may act faster at acidic medium. Now, enzyme inhibitors refer to any substance that can diminish the velocity of an enzyme catalyst reaction. They can be reversible or irreversible, meaning pwede sila mawala or pwede sila magstay sa isang process, and they can be competitive or non-competitive. Now, how do we differentiate the two? Now, in this table, we differentiate your competitive and your non-competitive inhibition. Now, let's first focus on competitive inhibition. In this case, there is a competitive inhibitor interfering with the active site of the enzyme so the substrate cannot bind. Nangyari dyan, think of two people na naniligaw sa isang tao. So, paunahan sila. Diba? So, with that said, yung ating bida, si substrate, nagkakaroon ka dyan ng low affinity with the enzyme kasi nga, hindi siya nananalo sa kanyang kalaban. And as mentioned guys, na may kainis constant will increase if there is decreased affinity of the enzyme to the substrate. Right? They are indirectly related. With that said, Km is increased in a competitive inhibition. Now, Doc, paano ka mananalo sa isang competitive inhibition? Kailangan mong galingan. Kailangan mo magpalakas sa ating enzyme. Kailangan mong damihan ang ating substrate concentration para ma-overcome mo ang ating competitive inhibition. That's the plan here. Okay? Now, Doc, paano naman ang ating non-competitive inhibition? So, dito, the inhibitor binds to the other part of the enzyme. And this causes a change in the active site or the binding site. Therefore, hindi makakonect si substrate sa ating enzyme. Okay? Dahil dyan, kailangan mong damihan ang ating enzyme na panibago para ma-overcome ang ating non-competitive inhibition kasi wala ka means para magkaroon ka ng reaction. So, dito, ang Vmax mo naman ang bababa. Kasi you have a decrease in the amount of enzyme that are active. Low amounts of active enzyme, low Vmax ka. Kasi Vmax and enzyme concentration are directly proportional. Now, para ma-overcome mo naman ang ating non-competitive inhibition, you have to increase the amount of enzyme concentration in a specific metabolic process. Now, there are different means of regulation of enzyme activity. You can have change in substrate concentration, allosterism, and even covalent modification. And of course, control of enzyme synthesis can also be a means to regulate this one. Kasi some enzymes are needed only under selected conditions or even certain life stages. So, it may take hours to days for control. Take note that the rate-limiting enzymes are the slowest step of a metabolic process, which determines the overall rate of the metabolic pathway. Doc, how does it make sense? Think of a group of people joining a Spartan race. Friends kayo, di ba? So, yung pinakamabagal sa inyo, hindi nyo kayang iwanan along the way. Kasi pag iniwanan mo siya, syempre, wala, kupal ka na friend, di ba? So, you gotta stay and wait for that friend. Therefore, yung pinakamabagal na friend mo is the rate-limiting enzyme. Thus, the whole process is a very slow process as a whole. So, that is actually fine in terms of enzymes in the body. If ikaw ay rate-limiting, kasi you can be a point for control via the effectors. Okay, kasi sobrang bagal mo, pwede kang magkaroon ng chance for modulation of the metabolic process. So again guys, rate-limiting enzymes ang pinakamabagal na friend na sumasali sa ating Spartan race. Okay? And that is all with your enzymology. Now, we discussed the digestion and absorption of your macronutrients, starting with the proteins. So, protein digestion starts first at the level of the stomach. Your pepsinogen, the inactive form, undergoes a process known as autocatalytic cleaving under the exposure of acidic environment. It will now become your pepsin, the active form of the enzyme. Pepsin will now convert chunks of protein into smaller, partially digested proteins and oligopeptides. Now, going to the lumen of the small intestine, the high acidity of chyme will trigger the release of your pancreatic enzymes into the second part of the duodenum. Also, the epithelial cells of the small intestine will release the enzyme enterokinase. This is the enzyme responsible for initiating the conversion of the inactive proteases into its active forms, as you can see in the diagram. Now, enterokinase will allow the conversion of trypsinogen into trypsin. Then trypsin will be responsible for converting these proenzymes into their active enzymes and also other trypsinogen molecules, becoming further trypsin, the active form. So the active forms of the proteolytic enzymes have different functions, and they are categorized into two main groups. Your endopeptidases, which cleaves proteins at internal bonds of the peptide chain, and ectopeptidases, which cleave single amino acids from the ends of a peptide chain. So we have here the following: trypsin at the basic amino acid sites, chymotrypsin and elastasis naman at the neutral amino acid sites. Both are endopeptidases. While carboxypeptidase A and B are both ectopeptidases. Yung isa nga lang A at the neutral amino acid, yung B naman for the basic amino acid. Now, digestion of protein does not stop at the lumen. Okay? Embedded at the brush borders are your aminopeptidases and other carboxypeptidases that further degrade your oligopeptides into amino acids, dipeptides, and tripeptides. The substances that can be directly absorbed by the enterocytes from the lumen are the amino acids, dipeptides, and tripeptides. Not shown in the figure, there are actually specific transporters for amino acids on the amino acid classes. If it is basic, acidic, or neutral. Now for peptides, they enter via a peptide transporter. But they should be further degraded into amino acids before they can be transported into the circulation. In the end, only amino acids are allowed to be delivered from the enterocytes going to the bloodstream. Now let's head to the digestion and absorption of your carbohydrates. Now, before we discuss the process of starch digestion, let's review the glycosidic linkages of polysaccharides, starch and glycogen. Alpha 1 to 4 is the linkage site representing a linear part, while alpha 1 to 6 linkages are at the branching points. Now, initial digestion of the starch occurs in the oral cavity via your salivary amylase thiolin. Now, thiolin is not actually essential in starch digestion, but important among neonates or patients with impaired output of pancreatic enzymes, because the major site of digestion of starch occurs at the small intestines via the action of your pancreatic amylases. And your pancreatic amylases hydrolyzes internal alpha 1 to 4 bonds only. So, 1 to 4 lang yung kanyang kayang sirain, not the 1 to 6 linkages. Now, to complete the digestion of carbohydrates initiated by your pancreatic amylase, we have brush border hydrolysis, your sucrase, isomaltase, glucoamylase, lactase. Now, in memorizing tables, you don't have to memorize everything, as mentioned multiple times. Always find the trends and exemptions to the rule, for these are testable questions. In this table, all enzymes can hydrolyze your alpha-4 glycosidic bonding of maltose and maltotriose, except your lactase. And among the given enzymes, only isomaltase is capable of hydrolyzing the alpha-1,6 bonds found in the branching points of your carbohydrates. To add lang din, sucrase is also specific for your sucrose, yielding glucose and fructose in the process, while lactase is only specific for your lactose, yielding glucose and galactose in the process. In terms of absorption, only monosaccharides can be absorbed by your enterocytes. On the other hand, the constituents of protein that are directly absorbed from the lumen are amino acids, dipeptides, and tripeptides. Now, as you can see here guys, your SGLT1 can absorb glucose or galactose coming from the lumen going to the inside of the cell, while GLUT5 absorbs fructose from the lumen going to the inside of the cell. Eventually, GLUT2 at the basement membrane releases glucose, galactose, and fructose into the bloodstream. Now, lastly, let's discuss the digestion and absorption of your macronutrients for the lipids. Now, before discussing the process of lipid absorption, let's tackle first the enzymes responsible for it. Gastric lipase is released from the chief cells of the stomach, the same cells producing your pepsinogen. They cannot properly hydrolyze your triacylglycerol. However, they are important among neonates whose pancreatic enzyme-induced hydrolysis is not yet fully developed. Now, pancreatic lipase naman hydrolyzes the first and third positions of your triacylglycerol, yielding free fatty acids 1 and 2 and your 2-MAG or your 2-monoacylglycerol. Now, the funny thing is that this pancreatic lipase is intrinsically inhibited by the presence of your bile acids. Now, to allow proper functioning of this enzyme, we must utilize our co-lipase molecule. It serves as a bridging molecule that binds the bile acids to your pancreatic lipase, allowing the function of pancreatic lipase to happen. Now, other enzymes involved include phospholipase A2 to hydrolyze your phospholipids and cholesterol esterase to hydrolyze cholesterol esters into cholesterol and free fatty acid. Now, to emulsify lipids, bile acids are required. These are substances mainly synthesized by the liver, and they serve as biological detergents that facilitate the formation of micelles. Micelles are energetically favored configurations of lipid molecules when suspended in aqueous medium. Now, besides the aforementioned lipid substances, the fat solubles ADEC are also transported in these micelles. Unlike monosaccharides and amino acids, products of lipolysis are re-esterified or reformed inside the enterocyte. They reform your TAG, phospholipids, and your cholesterol ester. This process mainly occurs in the smooth endoplasmic reticulum. At the same time, your RER naman forms the necessary apolipoproteins for the formation of your chylomicrons. Chylomicrons serve as the main unit of transportation of absorbed lipid products from the small intestine going to the liver and other peripheral tissues. So, anong nangyari dyan guys, the chylomicrons will then travel along the lacteals of your gut wall, going to the abdominal lymphatic system, then cisterna chyli, then thoracic duct, then going back to the blood circulation. Now, lastly, let's review the fate of the different products for lipid hydrolysis. As mentioned before guys, the long-chain fatty acids are largely hydrophobic. Therefore, they can only be transported via the chylomicrons. Your MCFA and SCFA are relatively hydrophilic. Therefore, they can be readily absorbed into the bloodstream via absorption. Lastly, the glycerols are directly absorbed into the bloodstream via your aquaporine transporters, going back to the circulation via the hepatic portal vein. And that is all in my lecture for biochemistry, structural biochemistry, and nutrition. I hope na forming inyong confidence in tackling the language of the biomolecules in preparation for metabolism and nutrition. And of course, along the way, guys, I hope you learn new clinical correlates and be useful not only in biochem, not only in the PLE, but also in life as a future practitioner. So stay safe, guys, and see you around in our next sessions in Top Notch for this season. Ingat and have a great day. Paalam!